This time, it's gonna be a special episode. We're gonna do a code review. And we're discussing what could we code review, and like on one hand there's lots of public code, but if you do a kind of like a code review of a public thing, then it's kind of unasked for, like you kind of are targeting somebody.
I never asked for this.
Yeah, and it gives sort of weird vibes. So we thought maybe we have some code that could be code reviewed. But then most of my work, for example, for companies is just proprietary. I cannot share this. I don't have any rights to share it. But Anton, of course, perfect Anton, had his exercises from university times.
Not quite, but yes.
When he was doing graphics in C++. And it has all sorts of things in it. All sorts of them. So we're gonna do code review of Anton from the past and see how much modern Anton was back then, before he became cool, low-level C almost guy.
Yes. And so I dug up some code from 2008, which, if I understand my years correctly, I would have been at university. This was before Sony any work experience. I would have been in university. I'd be 23 at that point. And I think, judging by the code, I'm pretty sure this was the phase where I wanted to write a space MMO opera, as you do, because everybody at 23 is like, I'm going to write an MMO, right? So you're not going to write a Tetris clone. Like, that's stupid.
Yeah, of course.
So of course I made a framework for this game, so that for future game projects, there'll be a framework that I could reuse. And I would have been, I think, taking graphics at the time. So a lot of this code I was probably writing basically in parallel to my graphics course. So I actually couldn't dig up the code from my coursework, unfortunately, because that would have been kind of interesting. But I did dig up some games I was making on the side while I was at university, effectively. And at that time, just to set the stage, I've been doing Kung Fu. I was doing Kung Fu at Stanford. So, Wing Chun Kung Fu.
Barely visible.
Barely visible. There you go.
Okay.
Stanford Wing Chun.
Wing Chun. Hi everyone. Let me take a break to thank members of the show who made this conversation possible. Members get earlier access to videos, including longer unedited footage from live streams, as well as they're invited to our private Discord server. If you want to support the show, there is no better way than becoming a member on YouTube or Patreon. Thank you so much.
Okay. So I would actually drop. I didn't live on. So I went to Berkeley. And I didn't live on campus, and Berkeley was about an hour from my house, and Stanford is about an hour from Berkeley. So every day my commute would be like an hour into school, do some graphics, and then, or whatever courses I was taking at that time, and then I would hang out in Soda Hall, which was one of the buildings, just sit on the couch, and I would program games until about 5 o'clock, and then I would drive to Stanford for the evening Kung Fu class, and I'd do that from like 7 to 11. And I'd come home, code some more, go to sleep, maybe play some games, and then wake up and like do it all over again. And
Wait, what was your university that you had classes in?
Berkeley. Yeah, so I went to Berkeley.
Okay, but for Kung Fu, you were at Stanford.
That's right, because the Kung Fu is better at Stanford. The computer science, sorry to say, y'all's better at Berkeley, but the Kung Fu was better at Stanford. Okay. I just accidentally fell into it. I actually lived in Campbell at the time, which is like closer to Stanford in a way. So I just ended up in a Kung Fu class nearby there. So that was kind of like my triangle. I would drive through the bay, and that some interesting knockoffs came from that, actually, because I had lots of long periods in the car to like contemplate code and things. So we could talk about that as a fireside chat. And also I have some like thrilling Kung Fu stories that occurred at Berkeley as well. We can get into.
Can you drop like a bit of knowledge? What is Kung Fu compared to like other martial arts? Like how you would recognize somebody doing Kung Fu?
There's a bunch of different kinds of Kung Fu. The type I do is Wing Chun Kung Fu, which is if you've seen like the movie Ip Man, that's like what that is. But I mean, it's all just like martial arts styles, and there's like endless, flame wars, just like with console wars, like whose kung fu is better. And then there's like the MMA people show up, they're like, kung fu is awful. And then, whatever. So there's the standard drama. So you can't really tell them apart. But typically if you see people like doing Kung Fu Panda / Ip Man stuff, that's more Kung Fu. And if you see people like wrestling on the ground.
You have things in the hand, right?
No, well, we mostly do open hands, but we do have a pole form, a knives form, but that's like much later so I only learned that way later. Yeah, like double butterfly knives. So there's these big chunker like cleavers that you hold.
Really?
Yeah.
Okay, after Kitchen Nightmares, I'm gonna watch Kung Fu with knives.
I'll send you some videos if you want.
Of you with knives?
No, I actually don't know the knife form. I know the pole form, but I can send you the knife form. You can watch Ip Man. Watch the movie Ip Man and you'll get a sense for it's exactly what I'm doing. No. But I started around that time, so that's why I have this shirt. This shirt's literally about 20 years old. So I dug up my old Kung Fu shirts.
Nice.
And this is like my old teacup from back in the day. From a company called Hyphen, where my dad worked. It's an encryption compression hardware company. And so we had like all these, because we were poor. So like all the mugs we had were from like corporate events and stuff. Company, not all of them, but a bunch of them. So yeah.
I have like 15 t-shirts from different companies that I worked at. So, and this is like my daily rotation of t-shirts. So I can understand that.
So yeah. Now that we're locked into the era of 2008.
So 2008, which is almost 2 decades ago. Okay, it's gonna be super interesting.
I opened this code. I didn't look at a lot of it. I looked at enough of it to realize this is probably going to be pretty fun. But I figured what we would do is approach it like in a sort of archaeological sense, and then we look at the file list and be like, what do we want to look at next, and then just go from there. And if there's stream suggestions or Wookash can drive.
Okay.
So the first folder.
We can also do a poll every now and then. So
every now and then,
when we'll be like, okay, what's next? In the spirit of like old text adventures, we're gonna do a poll, and then like, okay, we go to this page.
That's right. So here's the listing, the full listing. So there's a folder called Framework, which is like my first engine kind of vibes. This is like when I was like, I'm going to need to use this code again, And so I was like, it's called Framework. And so framework.h is probably interesting I think it's just a bunch of headers, but we'll see. And inside, we have these files. There's another folder, which is Cosmos, which is the space MMO, top-down space MMO with base building and shipbuilding and everything. We'll see how far that got, because I actually got it to compile and run. So we can actually look at it. Yeah. But I don't know how to run it. So like there's no UI. There's all just hotkeys. So we might have to, if we want to dig into that, we might have to figure out the code, how it works. So there's the files inside there. And there's also this side project called Fire, which is the particle effects for this, I believe, because I think it shows up in there. But this one is kind of fun for graphics look. And then there's a later project, which we could save for another day, but look at the change of file names. They go from camel case to snake case. What's happening there? I think this must have been after I took C.
External influence. That's what
external influence. So 2011, everything goes snake case. And I write a thing called Evolve, which is a genetic algorithms kind of like artificial life simulation. And so the reason I pulled these, there's other projects, but the reason I pulled these is both Cosmos and Evolve depend on Framework. So we can see how Framework's written, and then we could also see how it's used.
Nice.
Yeah. And none of this, well, actually, I said I got it to compile. I lied. I got it to run by shoving DLLs that were missing and also messing with the config file until it opened in a window. But I didn't get it to compile because this is all written in Code Blocks, which is an ancient editor, and has a bunch of Code Blocks was legit, man. I was rolling Code Blocks on my ThinkPad for days. And so you can compile it maybe if you have Code Blocks still. I don't have Code Blocks anymore, but actually it's somewhere. But anyway, I didn't get it to compile, and that's part of the learnings here because after about 2014, whatever, I stopped having framework, and framework files just start copying into projects directly. Because even back then I was like, the framework thing didn't work. Like, I can't compile my old code. Everything is, and also these projects have a bunch of dependencies that I just don't have, like XML and things like that. Yeah. So
the idea that you kept framework for 3 years as your kind of engine layer is already quite stunning.
What? Why? I mean, isn't that like a standard?
For me, learning programming like 15 years later, I kind of like expected an SDK to have that. So I never had a piece of code that I would be reliant on for a year, right? Or more than 1 year.
What do you mean by, oh, that's wild. You mean like your own piece of code that you carried around for that long?
It's like you're building something. Maybe it was like a project or for a university. Maybe it was a game or something. You build something. At some point you say, okay, done. And you like never look at this code again. You never go back. You never like, and you work for a company. It's like, okay, you produce the code, like you maintain some piece of code. And then it's like, okay, you leave this company. Bye-bye. Like I'm never touching this again. So I don't have much code that like would come with me from project to project, or like to be some sort of util thing.
I mean, this is all personal code, but so I figured it would last a while. But ironically, what you described is actually better because it would have been better not to have a framework folder. It would have been better to do the same thing that like game developers do, which is they just copy paste the old project, remove the things they don't need, and kind of start from there. That's what I do nowadays. But back then, I was into frameworks. I was reading the patterns, the design patterns for C++. I was reading the C++ FAQ, and then later the FQA. Yeah. So I was in it.
Let's start then.
Let's start.
Where should we go first? You have?
I think I'll start with framework.h just to like get going, and if people want to suggest where we go from there, we can get going there.
Okay.
So it looks like we got old school header guards from before Pragma once. Look at that.
I never understood hate for Pragma. What's wrong?
It didn't
with
exist.
Pragma?
It didn't exist.
Is there something wrong with Pragma? Pragma?
We didn't have hash Pragma.
Okay. Now it's just normal to do hash Pragma and be done with it now.
Yeah, now it's fine, but back then,
I still do this, by the way.
Oh, you do?
Cilion is doing this when I create a file, and I was like,
really?
You know what? Let's keep it.
Wow. Okay. Okay. So, the idea here must be that you just include framework and you get everything. Because that seems convenient. Let's just include all the headers and all the code. So like whenever I start a new file, presumably I just do framework.h and bring in all my headers. So this will never compile fast in the long run, but it sure is convenient because the only header I need is framework.h. This is funny. Pointed this out. It's like we're only gonna have uint. The other ones don't matter. Like, yeah. And so it looks like there's some init going on. Init and some things. Init and some framework. Font TS.
So the type defing, because this is like a common trope of like C project, especially this like framework key / engine things that you like start with like, here's my types, and then you have like a 1500 line of your types, and you have
just have one type,
and you're just like one. You're not even like floating points, whatever. You're just gonna like old school integer.
That's all.
And it's gonna be
that's
one.
all I knew. Well, I think it was just because like pragmatically, I was like, look, I'm tired of typing unsigned int, and also because C++ compilers like finicky. The space between unsigned and int causes all sorts of drama inside places. At least back then it would. So having it be one word was actually like helpful compile wise and macro wise, like for macros for sure, I think. So I think that's why that exists. And the rest are just like, I'll just use floats.
Okay.
Yeah. Namespace. Gotta have your namespace.
Branding. Build the branding, man. really branded for framework.
I'm curious now if this is used anywhere else or if it's just for init, because these other things presumably have their own namespace. I don't know. We'll find out. We'll find out.
Set
All right.
seed. Nice. Seed for a random number generator.
Yeah, so it looks like we set a seed. This one doesn't have a namespace. Looks like there's some IO initialization happening. Mosaic, who knows what that is. And font and TS. I don't know. What's font TS? TypeScript. Probably type. No. Ain't no TypeScript back then.
TypeScript didn't even exist.
No, come on. You couldn't. JavaScript probably didn't exist yet. Oh, no, it did probably.
Okay. But
All right.
By the way, hashtag mention const reference. Okay. C++ 2009 already into references. Okay. And default parameter. Default value for a parameter.
Well, if you don't know how to init the framework, I'll do it for you because, I'm good like that. Which are good defaults, right? Already, right? We don't want to. I wonder what the init params are or where that's even defined. Where's that even defined?
probably in one of the 50 includes.
Oh no. All right. And there's this one stands out for some reason. Why is there a space? This one's not like the others.
Yeah. Because it's more.
I'm going to peek in there real quick and then you decide where we go next. But I'm going to peek in here real quick. Oh yeah. Okay. It's just like, oh God, GL requires magic. So
I need to define it exactly once.
yeah. You don't need that. All right.
Okay.
Where should we head, chat?
Chat, do you have any suggestions? Where do we head next? I wanted to take a peek at the geometry, like
Let's go.
to see like math, but we can
Let's do it.
You can throw in suggestions into chat where you want to go next.
Yeah. We'll do geometry. Okay. All right. Okay. Questionable choices right out the gate.
math immediately include upstream. Immediately.
And just straight. We're just going to use vector. Don't worry about it. Using in a header, we're done. We're not doing stud blah, blah, blah everywhere. Yeah. This is considered an anti-pattern, right? It's like you're just blowing the namespace right into everything. But then it makes a namespace. It's like, if you're not going to have a name, if you're going to blow away all namespaces, why make namespaces? You're just making things to then blow away.
But why does it say using std offstream but not using name? Because using namespace std would be one thing. But
right.
If you want to say just for the offstream, you don't
say.
So
this is better than I thought. We're just grabbing those things into the global namespace still, but all right, still, because this isn't a header. And remember, this header resides in framework.h, and framework.h is everywhere. So you might as well just, but okay. Not bad.
At this point, like you can freely say vector of something without the std.
Yeah. Yeah, so you know where we're going. There's going to be a lot of vectors around.
Of course.
Yeah. Which was the thing back then, man. That's what you want to do. So I like how the epsilon is inside the namespace, but pi isn't.
Yeah.
Because I guess, All right. And so we're not in a namespace framework. We're now in a new namespace. So I guess we're just in math namespace now. All right. Let's see. Anything egregious pop out? Some degree to angle? Why not? Yeah.
I would say standard stuff. Inline. By the way, can we do a short inline talk? Meaning, when do you inline? Because the weird rule of thumb is like, if it's like kind of small, then you should inline it, and it impacts the both the translation unit, because it's gonna be copied all over. When it's gonna be copied, what does it really impact?
I mean, at this point, I was just like, I'm gonna inline everything that I want to be fast. That was my logic, I'm guessing, right? Because I just learned about inline. I'm like, it's faster to inline, so math has to be fast, so it's gonna be inlined. I don't think I had any concept of what ought to be inline back then. But even now, honestly, I think it's really hard to predict. And often, for the most part, the compiler will ignore this anyway. Like putting it in the header allows it to inline it, because I don't think it can inline it from CPP files. I mean, I know it's not supposed to. I don't know if it can in practice. I think if you do whole program optimization at link time, it can do some things, but I'm actually not super clear on those details. You can ask somebody who's more performance sensitive. But in general, you have to put inline if you're going to put the function in a header. And so for the compiler to even attempt to inline it, I think it has to be in the header. And for it to be in the header, you have to put inline. So actually, your intentions here are kind of null and void, because C++ is forcing you to put inline if it's in a header, because otherwise you'll get multiple reuse errors and all this stuff. So that's a kind of a nothing burger answer to that question. When should you inline? Realistically, you probably shouldn't most of the time these days. But for these kind of one-off math functions, I think it's definitely still worth it. But for anything that's like multiple lines and more than 10 lines or something, you probably are thinking a bit too hard. Unless by the time you know how many lines it takes, you already know what to do, I guess is how I'd say it. Like you probably know enough about performance to know when you should do it.
Okay, but this is inline inside the class.
Oh yeah,
for everything.
Yeah,
because the math needs to be fast, man.
Math needs to be fast. You got to be fast. So we got our normal. Okay, so this is sort of interesting because later on I stopped doing this, but I'm going with 0 init for the default constructor, which is not performance sensitive, but like honestly, it's probably the right choice. And then I stopped doing it, and it's probably the wrong choice because I was trying to be even more performant, but this is probably right. Yeah. Operator overload. Well, we need that plus.
But this is like standard for a vector class. Like if it would be game state and the overload operator class, then it would be questionable.
No, this is okay. There's going to be question. I feel there's probably going to be question because like this is already questionable. What is this? This is like the sign of
sign.
The sign of the multiply? What is that?
It's a bool.
We'll see where it's used. Keep an eye for op sign. We'll find out what this is for. I suspect it's used in like one function, which computes like the determinant or something. I don't know. Okay, I would actually these days put these into free functions. So instead of doing this kind of like thing inside the vector, also lol like class vector public, let's go. Just use a struct. I'd put this in a separate free function that just takes 2 vectors because it's easier to read and you can put them everywhere instead of having to put them in here. That's just stylistic. It doesn't make any difference, but
it would still be operator overloading. It means like
it would still
how it would be defined. Okay.
Yeah, I think hopefully people know it, but you could just basically do this. Instead of that, you just do this. And so you just overload the plus operator for 2 vectors instead of putting it inside as a member function. I think it's just more clean because this is symmetric. This one's kind of like saying add the right-hand side to the left-hand side, and this one's saying just like add left to right. And I think I just like that stylistically better. For stuff that operates on the contents of a struct, then I would put it as a method. But for things that operate across structs, I think it's always better to have free functions. Also capital vector, big typing.
Chat already picked up on like std vector being lowercase and vector being like uppercase, and like now it's like single letter from major confusion.
Vector of vector shows up a lot in the code. Also, like no concern for there being maybe a 3-dimensional vector one day. This is a 2D game, baby, so vectors are 2D. No vector 2, vector 3, vector 4. This is just the vector.
That's right.
Vectors. Yeah. Set 0. What? Why? This is not a useful function. It just causes confusion. Just equal it to a 0. But I was like, I'm going to get in my mindset. I'll be like, yeah, but if you do equals, you have to go through the copy assign operator and read the right-hand side variable. Here, we just set the things exact. Come on, man.
Okay, I'm not gonna say anything about this like attempted explanation.
What, you're not feeling it? You don't think?
I feel like when somebody's if there's a performance cut, like you take a performance hit because you don't understand that there's a copy constructor doing something, then there's like discussion to be had. But here in this case, it's like whatever you want to be like, oh, but that's actually gonna be like super fast. It's like on this level of like, mental. It's to me mental masturbation at this point. Like you kind of
100%. Well, that's what we do in college. At least part of what we do. We also learn.
You need to try things out. Obviously.
You got to try things. This is the first thing I was like, I need vectors. This is going to be my vectors. This is my log cabin from 2008. So, okay. Negate. Okay. I guess. Let's do it. Scalar multiply, scalar divide. Sure. Plus equals. Yeah, why not? Divide equals. Okay, bool equals. Questionable choice. Now that I know better, because it's basically there's a couple of different equals. Well, for one, floating point compare is just like a bad idea. So like,
point, no?
Yeah, these are floating.
When did we switch from
floats? Not everything is an unsigned int.
I saw the unsigned int and it was like 100% on ints.
Everything.
I thought it's like vector is gonna be int. Okay.
No, they're all floats. Using doubles here, so this would throw warnings all over the place now because it's gotta have the OF. But whatever. I think I just disabled the warning because like who cares, man? Conversions from double, who cares? So this is questionable. It's still useful sometimes to compare it to 0, for example. It's pretty safe. Well, compared to 0, if you're assuming it hasn't been changed, is pretty safe. But this one is questionable because this is basically deciding that this is and as opposed to or. And so if you look at like GLSL, in GLSL, operator greater than or operator equal, they'll actually return a bool 2, and they'll just do a component-wise compare. And then if you want to do and, you would do all. So you would do all v1 equals v2, and that would be like the equivalent of this, x equal, you get the drill. And if you want the or, you would do any v1 equal v2, and that way you can choose by composition what you want to do. So that ain't good, but I didn't know any and all back then. I'm not even sure they existed.
In what case do you want to have a greater in vector in this way? Like you do like dot products, for example, you add them.
When something's out of bounds. In 2D, things are out of bounds often.
But then you still need to like understand what is out of bounds. Like is A or is the X or Y out of bounds, no? Or you just like kind of assume both and...
I think it's like if any is out of bounds, you can like error out or something, or ignore, or assume that they're in bounds. In fact, this for float vectors, I think you're right, it's probably less common. But for integer vectors, it's actually if you have an IVEC2, we don't have it here, but like in GLSL, if you have like an IVEC2 index and and then you had like an IVEC2 dimensions. Just being able to like on a function be like if any index greater than dims or any index less than 0, like return, and that gets you two-dimensional bounds checking for a 2D array.
Okay.
Greater than or equals. Okay. Like versions thereof, right? So it's useful in the integer case for sure. Set length. Okay, I get that. That does show up. This is faulty. Mag is probably normal, or it's magnitude. Really, this should be called length because, like, but I guess magnitude is the mathematical term, so I was mathing. But the big problem with this is that like length could be 0, and then if length is 0, then this will be a divide by 0, and you get a nan. So the correct thing is really to not do this. You want to like do set length or. And then you can pass in like a vec2 fallback or something, and then you do something like this. If cur length greater than 0, then you can do this stuff. Otherwise, you return the fallback. Else. That way, like the user is aware that, hey, set length could fail. And then if you want to, the one that I just had, you do set length unsafe. So that way, if someone's like, no, I'm sure it's non-zero, then you have to type in unsafe to do that.
I like
safety first.
I like when chat is like, nah, I just assume it's non-zero.
Yeah, welcome to 2008. Bro, when I was 23, I assumed it's going to be fine too. And then you get a nan somewhere and spend like a day debugging it, and you're like, never again. So it looks like I gave up doing the rest of these inline.
Yeah.
It was like too much inline, man.
What's so reduced by?
Reduced by is cool. I think I know what this does. Vector. Circular vector iterator. Circular vertex iterator. Circular vertex iterator.
Okay.
Sure. Why not? Reduce by. So reduce by, I'm guessing, takes some distance off the vector. So I'm guessing, that's my guess. Let's see what it actually does. Where is it even? Oh, it's in the CPP.
Oh, damn. Was switched.
This one's not. There's some things in the CPP. Look at all this. There's some things. There it is. Yeah. So, op sign. You found it. Look at that.
So it did A multiply B greater than 0.
Dude, what does this mean?
So it's like if you have two different signs, like positive and negative, it will be false. And if you have both the same size, it will be true.
What is this function for? This is not clear to me. Reduce by... So this is like... I don't know. I thought I knew what it does. I thought it would reduce the length of the vector, but no, it's reducing a vector by a vector. Okay, do we actually want to figure out what this does? Is that an interesting exercise?
Yeah, let's take a second. Let's
take a second.
Let's take a second. So op sign would be like, hey, if x is a different sign than x minus vec, so it would be like absolute, but boolean.
Okay, let's draw this. X. So you have a vector. You have x. Okay, so this is like the difference between. This is the other thing. Is this confuses me because of the local stuff. So like x's are obviously the local member variable, and this one is the right hand side. Okay, so then, so you're subtracting. So it's trying to subtract, I think, this vector from because look, the basic thing it's trying to do is subtract the right vector from the left vector. Okay, I think I know what this is doing. I think this is saying subtract the right-hand side from the left-hand side, but don't flip signs. Not only if it would not flip the sign. So it's kind of like, I bet this is used for like drag or calculations or something. Like it's trying to reduce a velocity to 0 using some kind of...
And it's a clamp, like it's a minimum.
Yeah.
Because it says, okay, if you were to just reduce it below 0, then you just keep it at 0.
And it's like,
so it's like,
well, but not quite. But it's a sign. Signed clamp. Because if it's a negative vector and you subtract a positive, you won't clamp. So you can't just like okay, vec2
I agree.
better reduce.
I agree.
I think so, right? Something like that.
Yeah, because but that's, I don't know. I'm wondering, where have you needed this?
I think it's probably some kind of calculation that's trying to reduce the velocity of something. So something is flying and like there's drag or some kind of resistance that's defined by a vector that's pushing into it. And so you want to reduce the velocity but not push it back the other way. So I bet it's for a physics calculation of some kind.
Okay. And then
maybe we'll encounter it.
It can be negative depending on the direction. Okay.
It's kind of, I would probably these days just do it in radial space or something, but I don't know, maybe this isn't bad. Maybe this has merit. Op sine. Okay, op sine. All right. We'll come back to it. By the way, I made this tea like ancient style because the nice thing about the black cup is you can't tell the color of the tea is in, so you can make it super strong and not feel bad about yourself, but I think it's strong as hell. 'Cause I'm starting to feel it right now. I used to drink like strong tea, so I'm understanding where all this code came from.
Nice.
Okay, reduce by. I'm guessing these are all obvious. Point cloud. I'm guessing this is for convex hulls and things like that. Getting some nice defines down here too. Why not? Keep it rolling. So some of these are outside. Just between. Yeah. This is all
I'm gonna
stuff.
interrupt to make to tell people who are joining in, because people are joining in, and
like,
I need them
what is
to
this trash
understand the
code?
context. Okay, so
Yeah.
here we have Anton, who is reviewing with myself code from his past 2008 code of C++ when he was young. How do you say this? Wee lad. Like when you say
Yes.
wee lad in the university, between kung fu and graphics lessons, he needed to do this, or he wanted to do this because he wanted to do space MMO. God damn it!
You gotta do this. But it was in 2D at least. At least it was in 2D.
Yeah.
So I had some. I managed the scope. Yeah, I didn't know how to do 3D art. Didn't know how to do 2D art either, but I thought I did. Okay. All right. Well, there's some pose.
Let's go Matrix 3.
Wait,
Let's
what?
go.
Okay, so a pose is a privately inherits Matrix 3 and then adds a translation and scale or rotation?
But because it's top down, so rotation you can have one float, because it's always rotation is from the top, right? I'm assuming it's just by.
What is this for?
By the way, do you even remember all the 4 ways of inheritance? Like, what's the difference between the ways?
So private is not going to give you, if I remember right. So if you have class matrix 3, private, I think, means that you can only call, like, you have your private state here, blah. You can't touch that. Protected means like kids and private inheritance can touch. And then obviously there's public. So I think private must mean I want the stuff of matrix 3, but I don't want to be touching it. Maybe it's just kids. I think it's just public. Kids can touch. I think private can't touch the private stuff. Because you can see it here. I'm calling, when I set the pose to identity, I also set the matrix to identity. So there must be state. So it's not like, abstract inheritance or something. So the reason this is weird is because clearly this vector T and R, like this is translation. This is almost certainly rotation. But then why are we taking the guts of a matrix, which for 2D, a matrix 3 encodes rotation and translation, among other things? So what's this for? It's like basically saying, I want a pose, but I want a matrix too. I think that's probably what this is for, is like, I didn't want to do a matrix, but probably GL wanted a matrix. So I'm like, whenever I set the pose, I'm going to also set the matrix stuff too. And so that way, when GL wants a matrix, I'll just give it this one. As opposed to what I would do these days, which is like, don't even do this, and then just implement, matrix. Matrix 3, get matrix. And then just like make the matrix. But probably back then I didn't know how, but I should have, because I was taking graphics.
Okay. We got a chat message. Private inheritance just means others can't see the pose inherits from matrix 3.
Oh.
Just that fact. So you cannot static cast matrix 3 from pose.
But it changes also what kind of stuff you can grab from inside, no? Or maybe it doesn't. Maybe you can still grab the protected bits. I certainly thought it was the other thing. So whatever I was trying to do, it's bunk either way. Because I'm just basically now carrying around a matrix and a vector and its duplicate state. And as we all know, it's less state. We need less state, not more state. More state.
Less state, the better.
I think this is the first thing where I would like really question the skill of this programmer. Like everything else, I'm like, yeah, whatever. But this is like, this bodge, man. This bodge. This bodge. But okay. All right.
With const edge iter, let's find the class that's forward declared here.
Const there it is. Ooh. Edge iterator. Okay. Polygon const iterator. Okay, we're getting into polygons now. We're getting iterator heavy. So polygons. Okay, there's polylines, which extend public point cloud. So I think the idea here was that, like, in graphics, if you have a bunch of points and they're not connected, that's a point cloud. But then if you connect them, then you get a polyline. And then I guess in some cases that becomes a polygon. And a vector of polygons is a mesh. Because, of course, that's a good way to express a mesh.
Can I call out this? I hate this. If you decided, like, if we're working in the same team, okay, and we decided that we're gonna use state vector and like all the other modern programming stuff, I don't care that you need to type the entire line of this, that. You don't get to type def it, okay? Like you don't get to do like, now it's called mesh. It's like, I wanna know what's underneath. I wanna know what type it is, okay? Like I cannot be like having this. I hate that.
I'm pretty certain this was like recommendation from the canon back in the day. Like, I think I read this from a book. This was like, because the book would be like, it takes a while to, some people say it takes a long time to type, but you can just define it as your type. And this way you build up your types in your program. And I'm like, all right, fair enough. Because we didn't have auto back then either. So I think you had to type, And I'm like, I'm going full bore here because I'm saying, I didn't quite do iter, but const edge iter. Like imagine writing this all the time, like for int I equals const edge, or God, it's not even const edge iter I equals polygon.begin. Oh my God, man. So, and then you're searching through it and all that. So yeah, polygon.
But that's hiding the type. Like that's the crucial part, Like that bothers me.
I agree.
It's now it's like less state the better. So let's have like one version of the program and then introduce our naming for everything that will hide whatever it's underneath and have like second version of the program. It's just like
don't try Forth, man. You ever try programming Forth?
No,
it's like all that all day.
I am afraid now. So many people have brought up Forth to be like daunting, and I'm like,
Forth is a thing.
I'm daunted, man.
There's a really good book called Thinking in Forth. It's a really fun read, and you don't have to know Forth to do it, and it will change your mind, change your brain of how you think about programming. I think it's a good book to know. I've never programmed Forth for real, but I'm a Forth enjoyer, I guess. would be the term.
Afar.
From afar. I'd like to do it, and every time I design a language, it always seems to kind of go Forthish. But right. So Polygon contains. Oh,
Here we go, template. Here we go.
template class vector editor. What? Why? What?
Okay, we should we should make a decision. Are we like
Yeah.
exploring more mathy stuff, or are we
Yeah,
going somewhere else? I'm gonna do a poll. I'm gonna do a poll at YouTube. Chat.
I'll scroll through some of these things just so people get look. We got Bezier splines in there, quad splines. My God, I did a lot of stuff back then. Contour. What's the difference between a
Elsewhere.
contour? Is a list of segment pointers. Okay.
List like std list, like not even. Wow.
Oh, for sure. Stud list of segment pointers is a contour, as opposed to a polygon, which is a vector of vectors. Okay.
That's good.
You can render it and you can write it this file. Look at that. You can write it out. You can compute contours from what? So you push back a polygon and then you compute a closed contour?
Wait, you have cont iterator? When a const?
It's a contour iterator. It's a non-const contour iterator.
Wow.
These are kind of. Oh, look, there's a location. Location is a IVEC2.
Okay, I have bad news. The public has
Gotta get out.
Gotta get out. 75,
You're right. You're right.
75% wants to
Let's
leave.
move on.
Wants to leave.
This is done.
Out.
All right, back to the file list. Coming back to the file list. All right. Geometry. Oh, why are we in insert mode? Handled. Are we going to give it a rating? Are we going to give it a rating? Let's give it a rating.
Okay.
What will we rate geometry out of 10?
What do we
Or
rate?
out of 5?
Like correctness,
Out of
like WTFs
Just some,
per
just-
minute, or like
Just total.
entertainment value.
I think we should rate code quality. Would you bring this
What?
into your
What?
Would you bring this into your project? How likely are you to bring this into your project if you had some geometry needs? You were like, I found this on GitHub. It does geometry.
Okay, maybe like because nothing will get anything
2?
anything over 5. So maybe it's like
It's
Okay,
not
then-
GLM. There's not too many templates like Eigen.
no, but like
Right.
honestly, not I wouldn't bring this immediately to my project because I would be too scared. But if we throw this condition out, I would say the code
Yeah.
was like okay-ish. It wasn't like too bad.
Like a 4.
The vector stuff, like the stuff that we looked at, it was like kind of like okay, expected operator. Well, like, this is what I would expect in the library. Some questionable, like now using this, now using that. Bit of type dev, but not too much. Like that. Mesh, hate that. I would say like 5, maybe 6, even like.
Oh.
I wouldn't rate it, but I don't know what's happening in the contour and like from what you scroll down. Maybe let's subtract 1 and give it like a 5. Or we can have like rating from you and rating from me.
Okay. 5.
Okay.
5. I mean, I'd probably give it more like a 4, but we'll go with 5. We'll give it benefit of the doubt. From 2008 perspective, I reckon it's a 5. Nowadays, you have better options. You're like, oh, I'll just bring in GLM. There was no GLM. I don't think.
There was no GLM. What are you
There
doing?
was no GLM. All right. Where are we headed next?
Okay. If chat wants to give directions, put them in chat. As far as I think, we need to do something that is not mathy now.
Yeah.
Language is tempting. I don't know what's
Okay.
gonna be there. Like language seems like, is it narrative? Like is it programming language?
Let's
Is it,
find out.
Uh,
Let us
by the way,
find out.
how far? Like, are we exploring framework or are we going like full list?
Oh, motherload.
Let's go. Let's go.
Okay.
Oh wait.
So this.
So
yeah.
chat really wants mosaic, and
Okay. Well, language looks short, so we'll
okay.
blast
Let's do
through
it.
language. It looks like it's language extensions, and then I think it might inform. Okay, so
Oh, it's
now
a
we've
language
realized
extensions. meaning
Extensions.
Programming
It's an-
language that I'm programming in right now. Wow.
That's right. It's like, here's the things I miss from the language. So let's add them, right? And let's call it language.h. And let's also include this into every single file of our program because it's part of framework.h, and framework is in every single file of our program. So turns out we have boost for each inside every single one of our files. And also we have boost now. Why? Just for each. Because back in the day, you couldn't do like for x in vector of x. You can't do that in C++, whatever version this is. So we had to do for each, and technically boost for each. And actually, you couldn't do that. You had to do this. So I was like, well, that's kind of ugly. So I'll define it as for each and sneak it into the language. So if you
This
see
is
for
why-
each,
This is why your for each have comma, which was
Yeah.
super odd when I saw this.
yeah. So there it is. So now we got boost in here. Boost dependency spotted. Some more type defs, again to the same thing.
Whoa. If def assert, undef assert, and if what? What?
Well, it's like if you have assert already, we're going to do our own, baby. So let's undef it. Because otherwise it'll give you a warning saying you're redefining it. So let's be explicit here, right?
Okay.
Yeah?
I'm not, I never thought like this is because I just started programming later. I never thought like, you know what, this version that they give me from the language, yo, fuck 'em. I wanted my own version.
You gotta get that. Gotta get the swag going,
I would just name it differently so that there's no conflict and everybody knows that it's like my assert.
that it's different. It's too timid, Wookash. You gotta just grab that name and own it.
It's
like
framework.
It's framework, right? It's framework. Yeah, I probably would do the same these days because, like, come on, you're fighting with compile. Like, compiling this would be a nightmare. Probably mostly because of boost. Okay, so we've added char as well. We still have int, but just in case, we have a uchar too now. Fine.
Why is it defined separately for a file? Like if you're going full framework, why just damp your type devs in like the most top level, include, and then YOLO?
I suspect it's because later on I stopped including framework.h because I realized how much of a pain it is. So I started including like pieces from framework.h, and then I'm like, uint and uchar, I need those. I don't need any of this other garbage from framework, but I do need these, and therefore let's put them in here. I guess that's how it ended up there. So there's some like manually defined asserts and other. There used to be a thing called ensure that people liked, which is like runs and release. And anyway, whatever. So
Runs
there's
and
a
release,
tuple
but works. Like, well, so how does it differ from assert? It
I
runs
think
and
it's
release.
I forget what it means, but I think it's like the difference is like even in release, you want to make sure it doesn't run, but then why is it aborting? I don't know. It doesn't seem useful, but I remember this being like a pattern I read about. Loop. How does everyone
What?
feel about loop? Loop.
Define loop times.
Bro, you can do this. Are you tired of typing for uint I? You can just type loop 5 times. You know,
Wow, that's a
Float
nasty
A
level.
equals-
Like that's level, closure, not closure, groovy style syntax.
yeah.
Wow.
I don't think I ever used this. I think I realized immediately it was a bad idea, but whatever. Tuple. You need tuples because pair is no good. I don't think there was tuples in C++ at the time, or maybe I didn't like it. So there's some tupling going on. And bits. So this is actually, I think you see this in microcontrollers sometimes. Why does it only go up to 8? Who knows?
It's actually, I understand that. Like this level of like, how you bring in visibility to the bit magic. If you're not used to it, this.
Ironically, this is the one part that's commented out. So this is the one part we're not actually using. Okay.
Wow. Okay. 2 out of 10. Immediately. Okay. Chat. Give us the rates. Give us the rates for the language. We're gonna go to Mosaic because everybody wants to do Mosaic. Mosaic is such a cool name, and by the way, in phenomenal the Witcher series, book series, I have no idea how is it not in Polish because I just read them in original. But there is the storm, like something storm, like season of storms book. There is a person called Mosaic. If you know the reference, this is gonna be the most hardcore The Witcher reference. No, people are saying loop is out of 10 out of 10. Like we cannot rate language extensions based on loop.
Factor loop out.
There's 0 out of 10 as well.
Oh, 0 out of 10 for everything?
3 out of 10. No, I would say like 2. For me, it's 2. Like it's hacky loop, and then commented out things that would actually be useful.
Yeah. Okay.
Well, what's your take? What's your take, Anton?
I think the files should just be removed.
So 0. Actually 0. 1 out of 10.
I mean,
0.
I would refactor it out. I would put the asserts somewhere else, and I would put the loop is not useful. The bits are not terribly useful. It's better to define specific, like I don't really run into it that way. On microcontrollers, I do use that kind of stuff because like when I program Arduino stuff, there's often, but those are usually SDK defined. So, nah.
Okay.
But it's not awful. I ran with it for years, this code.
This loop got me places, man.
If someone finds loop, that's going to be cool. So maybe if we find loop. All right. Mosaic. I have a suspicion that y'all shouldn't get your hopes up because I think this is going to be a sad thing. The name is very cool. I remember what this does. Cool. But I think...
How long is it? It's over 100, right?
The header is small.
Okay.
The CPP is also small, which tells you why you ought to be disappointed. So Mosaic was my idea for a cool sounding namespace that does tessellation, because I was learning about tessellation at the time. So like, actually I found this. So this was my like reading at the time. So I was taking algorithms.
Okay.
Which I think Umesh Vizarani, I think, was actually my professor. I think. Oh, nice. I can't remember. And he's the guy that wrote this one. But then also these bad boys right here. Right. Computational geometry in C.
Yeah.
Yeah. And algorithm design manual. This has all kind of cool
nice
things in it. But
have you read them, like entire books?
I read them, like I've looked at every page cover to cover. I don't know if I would have implemented all of it or understood all of it, but I definitely like leafed through all of them. Because it's really cool inside. I mean, like look at this cover. Tell me if you see this cover, you're not like super locked in. You're like, you can't see that.
Well, okay. I see. They are kind of on a circle, different illustrations, right? Like.
Yeah, and look at all the. I mean, this one's actually more dull because it has graphs and stuff. and like lots of theory. But this one, the cool thing about computation geometry in C is, first of all, look at that tessellation. Look at the beauty. Look at that. Don't you want to tessellate like that? And then you look inside, and it's like just chock full of this kind of stuff, where it's like talking about graphs and loops and blah blah blah, and then like every page just has like different algorithms, and then it has like code, straight up C code in a book. Where is it? Look at that.
I think it's barely visible, but okay.
Anyway, it's a good book, and you read it, and there's like code in there, so you're like, oh sweet, I can learn how to do triangulation. So it turns out triangulation's like tricky if you ever tried it. If you have a polygon, if it's convex, and you attempt to just connect the vertices, you need to triangulate anything if you're going to render it. Maybe this is the good context to know. So like here, I'll do a quick drawing. If you have like a shape, right? Let's say you have a shape. Well, let's say you have a shape like this. GPU can't draw a pentagon. Actually, GL 1 point whatever used to be able to. You can just do GL begin polygon, and you could kind of do it. But you can only do it for convex polygons, because there's a trivial way to triangulate convex polygons. You start at like 0, and then you pick up the first couple, and then you do this, and then you have 3 triangles, 1, 2, 3, right? This is called a triangle fan. But if you try to do this to a polygon that has a concavity in it, what you get is, let's say you start from here, and you're like, okay, first triangle, this and this, and you're like, cut. Next triangle, this and this, great. Well, it would look like that, and you're like, oh god, this second triangle is wacky, and then the third triangle would be like this. So if you do that simple triangle fan algorithm, that doesn't work. And then you're like, oh, I have an idea. I'll put the thing in the middle, and then I'll like do that, and that sort of works until your concavity is like very deep, and then it doesn't work because now your centroid is here. So like very quickly you realize there's no trivial way to triangulate an arbitrary convex shape. So you get Computational Geometry in C, which is the book that tells you how to do what's called ear cutting, which is a triangulation algorithm which cuts off ears, which are the things that are not convex. So it would like cut this thing off, and this would be like an ear, and it goes bit by bit and like chomps pieces off, and you get something like this, and it triangulates your shape. So I was like, brilliant. I need this because I'm making a space MMO, right? And we're gonna have vector graphics.
That's the immediate connection that formed in my brain. Of course,
right? I'm not just doing this for funsies, you know. I'm not just, come on. So as you can see in our file list, there's a file called SVG. What is that? Well, that's the SVG renderer, because our space game is going to be in vector graphics, because pixel art wasn't really huge, I think, back then. Like, you know, obviously retro stuff existed, but that wasn't like the indie game style of the time. And I think, if I recall correct, this was the time like Newgrounds and Flash games were kind of peak indie in many ways. And so I was like, oh, if I'm going to write a game, I better do vector graphics like Flash. And I don't want those pixels everywhere anyway. Plus, I'm in a graphics class. How am I going to submit a project that's like pixel art? That's silly. So Mosaic was born, which was my attempt to do triangulation. But then the reason y'all should be disappointed is because actually this just wraps, I believe this just wraps OpenGL's triangulator. It just presents it as an API. So yeah, there used to be this thing called Glue, which is the GL utility library, I think. And all it does, it gives you like this tessellator object. It gives you back a soup. So really, this is just a wrapper around the C API of Glue tessellation. And what I do is I wrap that C API, which is already perfectly good, and I wrap it with a stud vector.
To make it better. Because those people better. In C land, they had no idea, okay?
They didn't know. They didn't know what's right.
Be taught, man.
They didn't read the books. They made these weird callbacks, void pointers to vertices. Like, absolutely, that's not type safe.
Absolutely disgusting.
This is gross.
So can we go? Actually, this would be super fun to now revisit. What was the API in C, and what did you return as your API?
So it looks, so the API in C, I think this is it. I can't look it up exactly, but I think this is bringing in the functions from it. So begin callback, end callback, edge flag callback, vertex callback combine. So basically, I think the idea is this: the C API is like you begin your what you're trying to do is you're trying to give the tessellator a list of points, which are like the points that I just showed you on the polygon. And so it has an API to give it points continuously. And then at the end of it, it's going to give you back a triangulated version, which is going to be like an index list if you're familiar with OpenGL, kind of like indices into vertex buffers. It's going to give you the list of vertex indices that makes those vertex coordinates into a triangle soup. And so you can kind of see how the API shakes out. So I wanted to make it so that you just give it a polygon. And then it, like, basically what I wanted, I'm pretty sure, would be like polygon, well, it's not really a polygon, right? Because I guess it would be mesh, triangulate, polygon, const polygon, poly. That's what it should have been. Ironically, with all the type defing and, classes, I don't have this type signature. I end up with this thing. We're like, I don't know, maybe it's somewhere. Simple triangulate. Okay, no, it is. Okay, no, it did work. Okay, simple triangulate, complex triangulate. So simple triangulate probably means that it's not convex. Complex triangulate means it is convex. And yeah, okay, no, I'm being too harsh on myself. No, I did have a good API. You take a polygon and you get back an index list into that polygon.
Okay.
So that's the API I wanted. And then you can draw it, I guess, too. Oh, I see. Okay, you can't draw anything without triangulating. And sometimes I just wanted to draw something one-off, and it was small. So this probably like does the triangulation and drawing at the same time. Okay,
And you didn't. You tries. Tries is not for trying. Tries is for
triangles.
Triangle
Yeah.
soup. Okay.
Yeah. Try soup.
Okay.
Yeah, it's not bad. So a triangle soup is just a bunch of triangles.
Tries.
Lazarus of tries. Yeah. Try. So warning, these are dangerous assumptions.
Okay, but it actually ended up being sort of similar API anyway. Like it's not that crazy. I was thinking that it's gonna be like, here's a class, and now this class has setters, and then you like two, and then like if you call some function and like
no, it's not too bad. The comedic value is low. Basically, it wraps an API that's kind of immediate mode, where you start the tessellation. Like here's the actual glue tessellator. So you do glue begin tess contour. Must be where I got the contour naming from, because it's talking about contours. You give it a test object, which I guess I'm using the global one. And then it just adds a bunch of vectors, calls glue test vertex, and end contour gives you back stuff. And so really, like, basically I didn't want to do these loops everywhere, which like starts the tessellator, adds all the vertices, which is fair enough. But probably what it should have been is like, I don't know. Anyway, I don't know. That's what I was trying to do. So the sad thing is there's no actual like triangulation code in here. This is just a wrapper over the glue API for tessellation.
Okay. And the idea is that you send data that you send the data anyway to GPU through OpenGL yourself, and then you just say the indices where the triangles are, and then you get back the indices.
Yeah.
Okay.
Eventually you just draw the triangles with but the thing is, GL wouldn't do this on the GPU or anything like that. This was just like a CPU utility function that would do these things for you.
The triangulation will happen on CPU, so why would you get why would you get the indices?
The indices? Well, what you need to render ultimately to submit to OpenGL is like, you have your vertices, and let's say they're like in order of 0, 1, 2, 3, 4. And so for the GPU, what you need is a vertex buffer, which is going to be the positions, right? X, Y, X, Y, X, Y. But then you also need what's called like an elements buffer or in GL parlance. And that's going to be like, okay, what's my first triangle? Okay, my first triangle is 0, 1, 4. So 0, 1, 4. And then the next triangle, it's going to be 1, 1, 4, 2. 1, 4, 2. Right? So you need to get this array.
Yes.
And you get this array from triangulation.
Yes. But it references the points, right? Mm-hmm. And the points are where?
The points are in that stood vector. And so at some point, I'm going to be like, in CPU.
Okay.
So I'm doing a whole lot of stuff.
Yeah. Just put it. Okay. So it just says, this is just an index to your std vector. And you still need to. Okay. So I thought that it's going to be already in somewhere on the GPU, and you just get back the indices, but they're already there, prepared to be. Okay.
Yeah. So then at some point, this will have to go onto the GPU. Okay. Yeah.
Fair enough.
Yeah. Okay. So, not bad, but, well,
Let's see. What's the rating for Mosaic?
What's the rate? Chat wanted to see it, so chat's got to rate it. I feel like this is
I'm gonna do a proper poll. Okay. Wait. I didn't end the other poll, and okay. A rating for Mosaic. I'm doing this on YouTube because there's more people. I'm sorry. I'm really sorry.
Okay.
For everybody who is on chat.
I'm not mostly following the chat, so but I am curious about this warning. Somebody discussed warning. These are dangerous assumptions. List guarantees the iterator to remain valid after insertion. So vector wouldn't work here at all, for example. But it's not necessarily true that the raw pointer, the address of the dereferenced iterator, will remain valid. Whoa. So someone read the C.
Whoa. Tread lightly. Wait, no.
Tread lightly, my friend.
These are dangerous assumptions. Like that there is a first, like the reference of the pointer, or what is dangerous?
So I think what this means is I read the C++ spec and I was like, what? Well, not the C++, but like the std library step. And list guarantees the iterator to remain valid after insertion. Right? So, but, like we know, like pointers to vectors won't work. But this is probably me just thinking like, but what if, because the standard library implementation is not like strictly defined how it's going to implement it, it's not necessarily true that the raw pointer from that iterator will remain valid. So what that means is if the iterator somehow had an indirection and you didn't use the iterator dereference operator, like it could be that, if I insert it into a list, the iterator remains valid, but it moves the memory from underneath entirely and just updates its indirection from the iterator. Because the iterator needs to use like, I whatever syntax, right? But this is operator overload. Could do whatever. Could return a different raw pointer every time. Who knows? So it's guaranteeing that you can hold this guy, so you can technically make an array of these guys, but it's not necessarily guaranteed that you can make an array of the things it points to. See that?
I am more confused. If we were to end Mosaic without like going into this comment, I would be like, it's perfectly fine, go. And now it's like, should we actually care about this? Like, maybe we shouldn't do weird things in operators then.
Well, this is sort of how you build up your PTSD around the std vector library, or the std library, because like, you can't really tell from the spec. I mean, okay, in practice, no sane implementation would invalidate the raw pointer to which a list points. Like, that would be bananas, right? But just like C++ undefined behavior, I think it's, at least at the time when I read it, it didn't make it clear that that couldn't happen. And because operator overloading is magical and stud containers are magical, and they really, really try to hide the pointer from you, it's not a crazy assumption to be like, can you get those pointers? I don't know. So yeah, we can go into what I mean if you're curious, but I this is probably super paranoid, but the paranoia is like, I read the spec, I'm still paranoid, kind of thing. He didn't tell me.
I would just probably run it once, and if it worked once, I would assume it will work 100% times. It's just like given, and
right.
I shouldn't be paranoid, I think.
Well, that's what I did, right? But then I'm basically, releasing my paranoia into the comment and basically saying like,
to feel better.
To feel better, right? And this is the beef I have as an engineer with the spec, and like, if the spec doesn't tell you you can get the pointer exactly, it says the iterator. It's not precise enough to tell me. Maybe it did. Maybe I just didn't read it enough or something. But anyway, this indicates that I read it and didn't quite get the guarantee that I was hoping. Anyway.
Nice. So I ran a poll. I didn't include 9 to 10 option because I think Mosaic will not get 9 or 10. Then I was roasted in chat because of that. And most people opted for around 4 and 6.
Okay.
Mosaic. It's like a safe choice.
It's a wrapper. It's a pretty decent wrapper over if you didn't like the multiple callback version, you get a wrapper. It's a wrapper.
Actually, I am surprised by like the solidness. I think for me it's a solid 6. Out of things that we've seen in geometry, I think it's a 7.
Oh my god. Well, Chad didn't give us a 6, so we'll give it the highest rating Chad could muster. I mean, it wraps a thing that works. That's all it does. Like, a thing worked and I didn't like the API and I spent like hundreds of lines wrapping it. It just added more duplicated state. So I don't know. Not bad.
I started a new poll. You can take a look if you want. You want to vote. You want to vote. You can actually vote.
We can also at some point. I think we should definitely get into here at some point. Because this thing is 32 kilobytes. There's things in there.
Okay, how are we on your time?
I'm okay. I've got time. But we should probably stop by here. And then we could also get into some gameplay code if people are interested.
So it's getting stretched a little bit. And I feel like we might do Cosmos the other day. If that's...
Maybe. I don't know if we'll come back to this experiment, but we'll see.
Yeah.
People should think this is their last chance to see the file that they want to see. They may never get a chance to see this code again.
So I'm thinking kind of that we need to do like 2 more. Okay. One is currently in the poll. So it's either Painter, Random, IO. I don't know if you actually can change your vote, but that's the thing. And then the last one would be SVG. And Cosmos.
Close it out.
Cosmos we'll see. Cosmos is like Cosmos. We cannot
endless.
grasp it. Like, it cannot be like come and see Cosmos, man. Like, come
on.
Let's have some humility, Like, it can't be just like doing Cosmos as like last 10 minutes. So Painter is a little bit ahead of IO.
Okay. Let's go.
I think officially end the poll now.
It's probably also under, let's see, you can kind of judge by the 7 kilobytes of Painter.
Well, that's some
Okay.
Painter. That's some Painter, man.
Okay.
The scroll
So
bar is-
Painter looks to be a wrapper over GL.
Damn rappers, man.
So it's like, oh, I don't like typing GL vertex to FXXY. I'm just going to add GL vertex vec.
But you have your own vector, so you have to
I have my own vector, so I have to do this. String is somehow getting into here for painting. Questionable. Map.
Questionable.
And a single color, which is red. Define color, red. So just like we just have uints, we also just do reds. This must be like Soviet backchannel programming. It's like GL rotate. Same thing. It's like,
wait, you have GL translate for your vector.
Yeah.
Understandable. You have your own class for vector, you have your own map, so you need to have the proper GL translate. But then you have GL translate float x, float y.
because I don't want to type the Z. Because it's a 2D game, Wookash, and GL keeps asking me for the third thing. So I'm like,
Wow.
no, it's 2D. It's 2D.
Okay. Wow.
Yeah. So we're using GL as a 2D drawing, accelerated 2D graphics API. Same thing with this. I can never remember I think this is probably easy, but I think what I couldn't remember is it GL rotate F angle XYZ, around which axis, or is it, XYZ angle? And I remember having to keep checking the spec, be like, which one of these is it? And no autocomplete back then, especially in code blocks. So I was like, all right, I'm just going to simplify this. GL rotate, it's in 2D. So it's always Z axis. Put it in there. GL rotate.
Out of
So
all
this is
these
useful.
weird, let's remove one letter from a function and wrap it. I think that's quite.
This is a
quite
good one,
nice.
right?
Yeah.
Scale. Scalar scale, no problem. GL vertex pointer. Again, this is me basically reading the spec for GL and being like, I never want to read this again and figure out what goes where. So we're just going to be like, this is our vertex pointer. It takes 2 floats. This is our color pointer. It takes 4 floats. That's how we're going to do it.
Would you do it right now, today, or?
Probably not, because I'm not going to write raw OpenGL. Back in the day, writing raw OpenGL was not super crazy. Now it's sort of you probably want to wrap it into a graphics engine of some sort and use OpenGL as a backend. And really, you probably ought to not use OpenGL anymore, even though I still kind of use it sometimes. So I think if you do anything complicated, you very quickly end up with a proliferation of these kinds of functions, and then it's just this is dumb.
I meant more if you were to do your own game engine from scratch, as everybody does every month.
Right.
Would you
I do this kind of
these
stuff?
wrappers, or would you be like, hey, I'm gonna type out this function, and after 4 times I will remember this?
I'll never remember it. I have never, I still type GL code to this day, and I never remember the order of arguments for GL attribute, GL vertex pointer. There's always float, num float, bit components. There's no world where I would remember, but I wouldn't wrap the functions because in practice, wrapping them doesn't really help. What helps is wrapping the entirety of the OpenGL stuff. And so you read the API and you do the right calls in the right place, but then you wrap the whole renderer and you no longer deal with vertex pointer on a daily basis. You just have your renderer eat a bunch of vertices and draw them for you. So that's what I would do these days. But back then I didn't kind of understand what a graphics engine would be for. And I thought it just sort of meant all the OpenGL code is my graphics engine. But really that's just raw rendering my stuff with OpenGL in the middle of my code. We have a color. For some reason, it takes doubles in, but stores them as floats.
Also, RGB and not HSV. Wow, very
just
questionable.
RGB, just straight up RGB.
I like the HSV where you can change the hue, saturation.
Yeah,
you understand what 0.1 will do to the value with RGB.
That's right. That's right.
No idea what's gonna happen.
Well, I mean, OpenGL ultimately can only read RGB, so I'm probably going to cast these colors straight in to OpenGL. So converting it from HSV, like I would, nowadays I'd probably do something like color, static color from HSV, and then float date. Right, and then in here, I would like convert from HSV to RGB. But then you don't get an HSV color, you just get an RGB color constructed from HSV. Yeah. And that way you pay the conversion on construction. That's probably a useful helper. Plus there's also much better color spaces than HSV, like OKLab or other CAM spaces or whatever. That's like a rabbit hole of its own right.
But then if you were to do like, hey, let's increase the saturation here, then you would like redo the calculations in HSV and then go back to
RGB. Yeah, and you have, I mean, for if you're storing like a color picker value, then it's better to store it in HSV exactly, because if you convert back from RGB to HSV, there's actually a singularity at 0 saturation, because you don't know if the color has 0 saturation, it's grayscale, and so your hue is undefined. So typically, color pickers will just slam your hue back down to 0, which will be red. But then you get this annoying behavior in some color pickers that are not well written, that like you have a HSV, well, not well written, but basically if a color picker stores its core state as an RGB color, when you slam the saturation to 0, no matter what color you were at, let's say you were like green, right? You slam your saturation to 0, and then you raise the saturation back up, it comes red, and you're like, what? It's because they slammed the value, and then anyway.
Okay. Fair enough.
Nah, no color is 0. Not a color is -1, and ugly color is magenta.
Nice.
Fair enough.
+1 on rating. Let's go. Also,
Scaled.
no color.
No color. Yeah.
No color. Very interesting. No color and not a color. Distinctively different. One is -1. One is 0.
Well, this is like
0,
null
0.
color.
And this is also 0, 0, but 0 alpha.
Yeah.
Which is...
Whereas this one is 1 alpha. Right? Because it's only 3 components.
-1.
This must be this must be a mistake. Missing alpha -1. Okay.
I mean,
because this is the default parameter.
To see negative values here, I don't know what math you are doing on colors to get to -1s.
Well, I'm guessing I just compare it to not a color, right? Okay, there it is. Is color? Oh, it just cares about the R. It's just like, if R is not a color, the whole thing's not a color.
It's optimization, I'm telling you. I see young Anton. It's like, we gotta go fast, okay? Ain't no time for so many comparisons, man. Like, just one. It's gonna be faster.
In the meantime, the tessellation is just like making vectors, moving these vertices.
You know, when they're like optimizing.
The comparison, we're just gonna do one. But the triangulation, it's slow anyway. It's fine. It's fine.
Oh wow.
Breathe. Okay.
But not a color. So you would just initialize things to not a color as a sort of sentinel value.
No, they're just uninitialized. Or wait, are they initialized? What's it initialized to?
I'm trying to find a way to.
Let's see. It's in the CPP. But here, like, look, the colors are initialized in the CPP, which means that the constructor, the thing that gets called the most, is like it's initialized to magenta.
I will defend this trick now. Valve used to do this, that if you have a texture, if you're missing a texture, you would actively, like, instead of like drawing the default or like that, you would draw something very bright so that you have, I think it was a half-life, so that you see that there's a problem and you need to fix it. So initiating color to magenta, very nice. But then compare it to the not a color and all the other things, it doesn't make much sense.
Like, it should have probably been not a color, but not a color can't be magenta. So I can see the struggle here of what I'm trying to define semantically. But like, why not just use ugly color, right? Because clearly that was my intuition here. Because I did a lot of like modding for Half-Life and whatnot, and I've seen the magenta, so I understood the reasoning. Also, this is pretty sus. Who just spotted that? Conversion from integer red to float red.
250.
Why is it 250?
Like,
Why is it 250?
couple short. Just a tiny bit short.
Maybe. I mean, it's probably not a mistake, but surely like having the decision that only these APIs will not access the full range of color, because I knew that the color was ugly. You know, colors are ugly when you get to the full range. Up to 250 is okay, but pushing it's like, this API, man, I don't know.
Why would it? So you would do, if you want to do doubles.
I know why it's. I'm pretty sure I know why it's doubles.
Doubles, but then you cast them to float immediately.
You know why? I bet it's because I wanted to type color C equals color 1110, and if I do that, warning, implicit cast to, and I was like, you know what? Give them the double constructor. It's fine. So then I could type this.
Okay.
Because I don't want to type the .fs, right?
Yeah.
Except it costs you every time you do this. So the irony of like, say, whatever. Everyone, I'm not going to beat the dead horse.
The int constructor. So you pass.
This part,
and then you do like the division. I mean the double float. Okay, this I get now. So that's the chapter closed. Understood. Integer constructor with division by 250.
Yeah.
You were dividing. So what you would call it with like 150, and then
no, you would just do color C equals color 128, 179, 255, and you're like, I want the blue as blue, but it's like you don't get the blue as blue, you get something else.
Yeah. So okay. So we still don't know why. Okay.
We don't know why. It could just be a straight typo. I'd be surprised, but
I would be just like you were just trying to defend, like not to get to zero.
No, I'm sure I wasn't. I was trying not to get to 255, but actually, now that I'm thinking about it, if I was trying not to get 255, I should have been dividing by like 270 or something, not by 250. If I divide by 250, I'm actually more likely to get to 1.0, right?
Yeah, you get 1.1, like over than one, more than one.
Then it's just wrong. It doesn't even make any sense. We're
trying so hard to find the explanation.
I got nothing. No, I think this guy's fired. But this one, well, I know why it's that way, because I intuitively think of opacity as 0 to 1, and I think everybody does. So doing opacity as a 0 to 255 just sucks. But this is actually defensible, like in the future me knowledge, because sRGB colors, you have actually R, G, and B are gamma compressed 8-bit, but A is linear. And so if you have an sRGB A color, technically speaking, the A component is a non-gamma compressed linear color, or should be. So I'm not doing that, but this API is potentially surprisingly smart. What a save. You like that. Wow. You like that. That's some interview techniques right there.
Wow.
Like, that's what I was thinking. I was reading about the sRGBA standard. Just didn't do it quite right.
This is how you save your technical interview, you know, like you throw in like an anecdote like that. And like, I cannot push you on that. I would not.
And move in. But keep moving.
Perfect.
Yeah. All right. I think we have enough colors. There's the actual drawing API. Draw convex. Okay. Polygons. Draw a convex polygon. Draw a star, which is a concave but radially symmetric polygon, which is also trivial to triangulate. Draw concave, which must call the triangulation underneath for you automatically, which is slow, but all right, whatever. So, I mean, these are performance terrible functions. It's basically saying, like, I just want to draw stuff, but, like, really, you're doing a really expensive triangulation for any large... Like, this is the kind of thing where I guess this is, like, the definition of naive, because you're thinking, like, I'm going to write this nice function that renders concave polygons, and it's just going to do it every time. I pass it a polygon, it renders it. And the truth is this can't ever be fast because triangulation is slow, so you have to cache it somewhere. So I suppose maybe I was like, well, I can cache the polygons and then maybe return the cached I don't know. But so you could argue that, but easier to just be like, hey, the API shouldn't let you do this kind of stuff.
What
Maybe
we really
not.
need is Triangulation Manager. Like a proper class. It would have a cache. And
Yeah.
it would be
Have
like
all your
an intermediary.
triangulations. Yeah. Or, I mean, lean in and be like, no, you can draw concaves and then it'll like cache behind your back or something.
Like accept cache as an argument, sort of to require.
Well, just global, static,
YOLO.
triangulation cache. Let's go. And then just like, you know, cache dot get poly.crc32 and just hope CRC is unique enough, and then, you know, if not, add to cache. That's a good way to speed it up.
Yeah, but then and at some point you'd like to be like, okay, but this cache shouldn't have more than X, like memory wise, because like it holds up too much and over time.
Yeah, no, it's a terrible idea.
Like, so, you know.
Yeah. It doesn't scale, but the dream is there. You can see the dream. I'm building the dream, Wookash. I'm here. I'm like, I'm gonna have a rendering library.
I get it. It's like, you know, I just want to call this code is all like, I just want to call this, and I just don't want to worry. Okay, like let me be free. You know, I want to be just call this.
Yeah.
Things happen, and it's like I'm gonna do it.
That's a good way to. It's trying to get freedom energy. So like all these overloads of APIs that I don't like typing, I'm like, I'm gonna make it how I want to type it.
Freedom coding.
Like performance be damned, freedom coding. So I mean, and that was the advice. A lot of the advice is like start with the call site. So I was like, all right, I'm starting with the call site. Draw polygon, looks good to me. So
Nice.
you know, maybe this is obviously that's good API design advice, is like thinking from the usage perspective first. But I guess this is like the naive dark side of it. It's like if you haven't thought about performance and you haven't thought about extensibility or scalability or any of that stuff. In fact, actually, it's really performance that pushes this. If there's no performance questions, there's nothing wrong with this API. Take a polygon, you draw it. It's like the only problem is that polygons are expensive to pass. I mean, that's why I'm passing it by reference. But like in theory, expensive to pass. So performance is the only reason this API is bad. Arguably, right? I can't think of any other reason. So if I'm going to interview defend myself and be like, well, I'm not doing premature optimization. All right. I'm working from the call site. It looks great at the call site. And if it's too slow, we'll optimize it later.
I didn't run it yet, right? So I don't know.
I ran it. It runs. I'll show you some triangulated ships and stuff. You'll see this code running.
All right.
And it runs just fine. It runs fast enough. 60 FPS.
Play into your interview defense.
I know,
like,
yeah.
I didn't run it yet, so I have no idea.
Right.
I cannot know. So right now, I'm in this like
Right
la
now.
land, and I can just do whatever I want, and I will.
I mean, I have an even better interview defense. It's like I ran it at 60 FPS, so it doesn't need to be optimized yet.
I ran it. It's fast enough. How fast it is?
Fast enough.
I don't know, but it's fast enough.
It runs at frame rate.
It really runs smoothly.
Yeah. So this is basically Mosaic front end, drawing all these things, drawing points, drawing lines, good old draw line. Draw line width is this is a disaster. Modern times, line width is not well supported anymore. Oh god, this is bad graphics programming, bad. But whatever, the API is good.
Couldn't have known 20 years ago, I think, because it wasn't
quite there. Yeah, that's probably true. That's definitely true. Yeah, bump that rating up. Look at all these cool functions: draw cross, draw square, draw outline rect, GL circle, line strip, line loop.
Why sometimes it's a draw GL and sometimes it's a draw directly?
So I suspect draw GL draws GL lines, which are screen space pixel thickness, and draw line strip probably uses scaled sizes that will take transforms into account.
Your world,
like world line thickness. I hope that's what it does. Yeah, GL line loop, GL line width, GL begin. Let's go. That's it.
Let's go.
That's
nice.
it.
A little bit of template at the end.
There's CVPs in there. There's some implementations. We won't look at them just in case they're real. This one's enough. This one's enough to give us a sense. Oh yeah, there's GL polygon right there.
So we're now approaching the rating of Painter, which is the graphics library for framework. Rating 1, 2, no. Rating Painter 1, 2, 3, 4, 5, 6. See, I didn't do 6, 7. I could have done it. Okay, I actually can't have more options than 4, so again.
The chat is on fire. This is great. I should record this. Please don't record this for your work.
Okay, I did 6, 7. It's not
there's an 8 out of 10. Oh, thanks, Wookash. I appreciate that.
I added 8 out of 10, but it's, 6, 7 is gonna win, not because it's meme, but it's gonna be like the most, how you call it?
Bell curve.
Yeah. Like when you do the NPA, the engagement score, what, NPA? Yeah. You always have like the 7 is the breaking point. The 8,
I see.
More than 8, you have the positive people and the attractors, and then you have the detractors below. So I'm guessing like 7 will be winning, but let's give it a little bit of time. As far as your rating, what it is?
That color thing, I'm not gonna lie, that gives me the heebie-jeebies about the rest of the library or the rest of the file. If I saw that in a GitHub file, I would run like the plague and be like, I'm not touching anything this person wrote.
But then again, like we kind of know that this is like university style program.
Student.
There was some sort of. It's not like it's not like a senior engineer job applicant kind of situation.
Fair enough.
It's more like you need to be like a bit easier on yourself.
So I admire the ambition of writing the whole library and having convex polygons. The completeness is good. You got lines, outlined lines, circles. I think I saw some circles in there. We got convex contours, which is non-trivial, using the tessellation library. Not as cool as having written your own, but not bad. You found it. You read the spec. So the fact that I have to bring in GL, GLUT or GLU or whatever to support this library is a downer. So, but yeah, A for effort. Definitely was thinking about rendering. I was thinking about rendering.
A for effort, 2 out of 10.
Is that what we got? 2 out of 10?
No. I'm just kidding, because it's an A for effort. It's like now we're in the like 8-10 zone.
Yeah. Well, I mean, basically, I think with all of these things, it's like lumpy. There are some parts that are not bad, and some of this code actually still looks like code I write, not color. Anyone who's looking at this, I don't write color like that anymore. but other parts,
especially my manager.
Yeah. None of this code happening. But, some of the other code, I still probably would have like functions that for debug purposes draw circles or whatever in a immediate mode kind of style. It's fine to kind of throw it out there. Oh, 6 to 7.
So yeah, this 6-7, I would say, looking back at what we rated the Mosaic as 6. I think that's like the strongest so far. Like
this one,
yeah.
Painter.
Yeah,
so we're gonna give it a 7. Let's give it the 7.
Yeah,
but I mean,
let's forget the color. Let's forget the color.
Okay.
And like people make mistakes. It's fine. All right. So now we're gonna review the last bit of framework for today, SVG. Should we be prepared, Anton? Like, should we be like?
Okay.
Should we expect something that's gonna happen in SVG? Because you mentioned that we should end on this. So is there a bomb there, or what's going on?
I didn't read through a lot of it, but just the reason I say that is because so far the biggest file we reviewed, and I know the font is small, but the biggest one we reviewed so far is geometry, which was 16 kilobytes header and 18 kilobytes CPP. And the rest of these files are like 12 is font implementation, so the font renderer is 12 kilobytes. But SVG is a whopping 31 kilobytes in the CPP file. So it's double the length of everything else and 8 kilobytes on the API. So look, the API is pretty lean and there's a lot of implementation in there. So I was like, that's why I think these are the ones. This is the final boss.
Okay, that's perfect then. Let's do SVG.
SVG, namespace VG, vector graphics. We're going to use a lot of it. So the namespace got to be short.
What is the
namespace
S?
Needs what?
Because it's SVG and then it's VG. Where's the S?
No, because this is a generic vector graphics API. SVG is just the file format, but there are other vector file formats, like Adobe Illustrator.
Okay.
So vector graphics, I'm guessing. Just got to save that letter. Even though the header is called SVG, lols, might as well.
Yeah. Okay. VG. Okay.
VG. Okay, so the high level idea, as I mentioned before, making space MMO, it's 2D top down, but we need art, right? We need art. We need to draw asteroids. We need to draw more asteroids, probably. I don't know. There's lots of asteroids in space. So we need vector graphics because we're not going to procedurally make everything. We're going to procedurally, and it turns out we're going to make procedurally most everything in that game anyway, but we need to load some art from an artist that might join. And it's going to be vector graphics art because vector graphics looks good and it doesn't have pixelation. So we need a fast vector graphics API. So we need to be able to read SVG files, output them as polygons. That's probably why geometry is in here. We're going to need to render them, even if they're convex, right? We're building up, right? We need to triangulate them so we can render them on the GPU. We're not going to rasterize them on CPU because CPU rasterization of vector graphics is slow. But it turns out, as I learned from my graphics course, that you can subdivide Bezier curves. You can subdivide them into points, into linear points. And once you have, because SVG is mostly Bezier curves and arcs and things. So we're going to linearize all of our SVGs. We're going to make them into polygons, which are a bunch of line segments or contours or whatever it is we're calling them. We're going to triangulate all that. We're going to take those triangle soups. We're going to put them on the GPU and we're going to render them real fast. And this did work. I can't find the demo, but I had a demo of the famous SVG Tiger image. Do you know SVG Tiger?
Yeah, I think so.
SVG Tiger. It's this thing, the Ghost Script Tiger. You know that one?
Yeah.
I had this bad boy rendering 60 FPS on my ThinkPad X61S. I remember that, or X61X or something, whatever, the tiny laptop with an Intel GPU, 60 FPS. So we got there. Now, it couldn't change every frame because we were running triangulation every frame, lol. But if you triangulated once, OpenGL could render that thing quick. So this code does work. All right, we're getting strings, we're getting vectors, we're getting series.
That's already like +3 to rating because
the fact that it works.
Yeah.
I mean, all of it works though. Yeah.
Oh
God. Okay.
Adjust the rating.
We might have to adjust all the ratings. Okay. So we have a draw style. I guess there's a lot of color happening. Okay. Sounds like there's an image, which I'm guessing is like the whole of it. Paths are what SVG calls like connected regions. So like a closed path for a chunk of SVG is called a path. Groups, I think, are compositions of paths. So we need to be able to... SVG Tiger is actually pretty easy to parse, I think, even though it's a complicated piece of vector stuff. I think it's mostly just a bunch of paths and groups. There's no like special stuff in there. It's just complicated looking. Okay, but we have our first pure virtual class element. Look at that. We have a pure virtual API.
Element string ID.
Oh, it's not pure virtual.
Effect.
This one's pure virtual, but these are not. Okay, so it's not an interface. It's just a virtual class with questionable inheritance options.
But you have to inherit this because you have at least one, right?
Yeah. Good point. So you have to inherit it, but you don't have to inherit all of it. But not all of it is inheritable. So you gotta know. You gotta read the class to know what you can overwrite. Now, what I appreciate is everything being on a single line, because at least I can quickly parse out what I can inherit and what I can't. The one change I'd make, I'd put these things like that. You know? Look at that. Look how much better that already looks, right? Not overridable, right? Then the rest is like have to. And then like could do, shrug.
This is your cabin. You can do this.
You
but you
can
can
do,
also accept the nulls. Probably won't work. But
oh yeah, they're nulls.
Actually, so it's like you don't need to do it. It won't work, but you don't need to do it. But the render, like, hey, get yourself together, okay? Just do the render, okay? You have to do it. And ID, you don't get to change ID, okay? You set the ID because it's a value, so you still set it. I guess it's public, so you can change it. But like, getting ID is gonna be, I'm gonna enforce that, okay? That's perfect.
Barry. This is like the
Perfect
freedom
class.
section. Maximum freedom to do what you wish. This is like the laws.
I'm this
here.
close to like politics references. I'm doing all my best not to mention ever politics on the podcast, but it's actually like if you think from like politics and what various groups stand for, this is like all this conflict in the same class, you know.
Yeah, this is the first principles. Like, I'm sorry, I can't give you this freedom. This just is what it is. Yeah. This is all the freedom, you know, with a star that I can give you. And this is like, you can't. We all agreed. We agreed on these things.
Exactly.
Okay. All right. And this is our private state. Nowadays, it's fashionable to put it at the bottom, but I like to put it at the top just so we know what we're dealing with. You know, special effect. Intriguing. Okay. Bounding box. Is it computed? Yes. If so, there it is. Mutable too.
Mutable.
Yeah. So.
Yeah. Please.
This is called memoization, Wookash. Okay. Have you read about memoization? It's in the books. So the idea. Yeah. Go ahead. Have you heard of memoization? Let me interview you
Yes,
back.
but it's like for the like interviewing like style of like algorithms for
Yeah.
just a different word for basically caching. But if it meant to be more interesting than that, then no.
No, it's caching. But it in the context of, clean C++, I would say, is it allows you to define some of your functions const, such as get bounding box, which is a function you want, and it is a const function semantically from the SVG perspective, because it's going to be the same bounding box all the time, unless you change the SVG, but I guess we're not. But if you call a function const, you can't actually cache behind the scenes, because that would mutate your state. So for that, we have a keyword called mutable to make a const API, but a mutable cache in the background. So there you go. Clean.
So it's
I don't see where get ABB is, though, but I guess it's a thing you might have to implement. Maybe. Why is it not a part of the API? So you've got the state, but you don't mandate. You don't actually mandate the API. Is it used? It is. Oh, it's in there. Okay, there's bounding box. Bounding box doesn't extend from that.
so you
Nobody
do use them in the classes that inherit.
Yeah, they're in there. Okay, so here, this is doing the thing. Look, it's got the const. There it is.
So what is it doing in the base class?
I have a suspicion that base class is unused. We might be spending our time.
Or is it like it should be common? Like everything should have like AABB. So, but actually, I don't have any use because there's no like implementation really for it. So
There's a path. Path is an element.
okay.
Computed bool, but there is no AABB. Maybe it's using the AABB as part of its internal work, as part of render const. Oh, maybe, because render is const. Because rendering is const. Rendering does not mutate our SVG state, so that must be const. So I bet that computes in AABB. Maybe. We'll find out if we get to it. All right. So elements are basically any kind of SVG element, I believe, if I remember the spec correctly. I haven't read the spec lately. So that could be a path, an arc. I think maybe a group is also an element. Not sure. But this is like basically your SVG entity equivalent. Transform. We're having the transform again. Didn't we just have this in geometry? This is this pattern again. What is this pattern?
We've
seen this pattern.
We've seen something adding the
it's pose.
And then, yeah.
Yeah. There it is.
But not transform, yeah.
Okay, so this must be like, all right, whatever. So this is my second attempt.
It's going to have matrix, okay. A vector offset? Off?
Oh, it's just an offset?
Offset of what?
What?
Oh, you add this in the
Oh, I just add it to the position. So it's just a matrix with an additional offset just in case?
Just in case you didn't want to add it. Or maybe you stored like local world coordinates separately. And
Probably it's for local stuff, yeah.
And you wanted to move it.
Local space. This is probably like a local space offset. It looks to be being done. Well, yeah, no, this would be in local space, I think. Yeah, because it's not applying the wait a minute. This is in global space because it's not applying the rotation. So this, I think, would be the equivalent of doing it in global space, if I read this correctly. But we can pretend that it's for local space. Yeah, it's probably for that. That sounds sensible. Okay, we're doing some composition. Cont array is an array of contours. It's actually a vector of contours, but who's counting? I guess. And so
nobody will, because we'll hide this.
We'll hide it. Well, no, it's public, but it's Exactly. We just have a cont array of conts. So cont array, so these are all the contours in the path? Can you have, I guess a path can have multiple contours because they can have, okay. Oh, someone in chat says path can have absolute and relative offsets. Indicated. Not my fault.
What chat do you have? I didn't see this.
I'm seeing the YouTube chat. I know Conta Rains. I just came back from Australia, so I'm definitely reading it in an Australian accent, but I'm going to reserve that. So we have a bunch of conts, and we're drawing them in a style. Fair enough. We got to make sure they're... Why is this just public, though? Okay. All right.
If you want to close it, if you want to close the path, you can always do that, you know.
You just close it up,
it's at your disposal. You can always
because I guess it's whatever. It is what it is. So I guess we're going to take all those things and we're going to do some stuff with them, and they might have to, because if you have multiple paths, you can have winding things and all that. I don't know. And you can also render them too. What does that mean? With an LOD. Hell yeah. All right. So it's rendering them to a point cloud with colors and index triangles. Okay, so this is basically kind of a mesh, even though I'm not using my mesh class, thank God, but okay. And there's an offset. Okay, so this basically renders them to an index buffer. And this probably renders them to the screen? Don't know. Could take bets.
Depending on the implementation.
As a path, if it's a path, as a path, it's this. Fair enough. Also, this is a const path.
Inline for performance.
That's right. Yeah. Don't you have to do like final these days or something?
And the const, again, I'm not like, I don't know all the rules, like the FAQ and FQA, like the number of exceptions and like weird rules coming from const, it's just const, is staggering. But honestly, I would just give up and not do const here.
Yeah.
I would be like, just return. Let's not do.
But I'm trying to learn how to program. I'm in university, right? And I'm being told that. Oh, you know what?
What I meant was more like a question. If you were to do it now, would you give up doing the const
absolutely.
part? Okay.
Absolutely. I mean, I sometimes do const for arguments to make things a little bit more clear if it's a pointer. Like if you have a const pointer coming in, that's clearly an argument, whereas if you have a pointer coming in, then it's usually like a return value, and I try to avoid like in-out values for returns if I can, try to be more functional. I still sometimes slap const here and there.
You have only in and only out.
I try. So like if I have a function like void stuff, right? If I have so const thing arg is clearly an input, right? And so if you have a signature like this, you know this is like a really confusing function. This must have side effects because it returns a void and it takes a const. So this like probably has side effects. So just from a readability standpoint, I'm like, okay, this tells me something. If I have this, I'm like, I hope it's functional. Shrug.
Yeah.
Right? And then if I have this, then I'm like, I guess it alters arg and returns something about it, right? So it starts to get like more and more vague what things do. So it's kind of, usually my preference is like, result or something, and then const thing input, that kind of vibe. Then I'm like, oh, I know what this does. This takes input and outputs into result. This is very clear, right? So I use const in these kind of places to help the readability of things. But that didn't exist back then. Okay, then we got some iterators. All right, okay. So path is an element, has computed and closed, okay. Group is an element. Nice. It's a this, if it's a group. It can be rendered to. It has a trans, okay. has a style. Did Path have a trans? Path didn't have a trans. Okay. It has UBOs and VBOs. There's a lot. So basically what this means, OpenGL, vibrations happening. So we have as many VBOs as paths in the SVGs. Let that sink in for OpenGL enjoyers. That's a lot of VBOs.
Wait, what?
Yeah, basically I think I'm going to allocate a VBO and color try and vertex VBO for every single path.
Oh,
because I'm going to render them
one huge and just put the data in. Oof.
One draw call per path, baby. We're going.
Well, because it's actually it's like super good C++, no? Like you have everything
it's contained.
encapsulated.
It's contained. It's encapsulated.
It's like the disease is contained and like everything is great, you know? So like how would you ever do it differently? Like you would then spread this out like madmen.
Yeah. You just can't. You don't know. And there may be a saving grace here, interview hat on, which is that if you have complex composition styles of like opacity and stuff, you may need to be, at worst case, a draw call per path if you have effects that require shader changes between paths.
But even then you could have like them grouped by layers, right? And have vertex buffer.
Or you could just still have it in the same VBO, but just change shaders, but don't put the VBO in the class. Like, I don't think there's any reason for that, but anyway, you may have to still do a draw call per path. Maybe, but probably not a VBO per path. Hard to justify that one. I tried.
Interviewer didn't like it.
Yeah, interviewer makes note. Questionable bullshit answer. Okay. Groups are a vector of element. Pointer. Dun, dun, dun.
Oh, pointers
okay.
and vectors.
Pointers and vectors.
What present Anton doesn't like about past Anton.
You can see where it comes from. All right. And you can flatten it. I guess we're going to be flattening things maybe. Okay, and a graphic is what looks to be a single VBO with all of the stuff. Okay, so probably what might be happening is that if you really want to go fast, you can do a render to, and there's an offset, which will offset. So this is the high performance ejection right here. Nice. You can render to a single VBO if you want.
So you
that's
have
it. I mean, you know, you have both. Just have both.
I like.
Why not? Yeah, it's not bad.
I have both.
Yeah.
It's like, you know, actually, Mr. Interviewer, like, I have both encapsulation and fast performance, and you can choose. Okay, choose your.
You
option.
can choose when you get, you know, when you start, you just do the simple thing, and then when you get better, you can render to, you know, into a graphic. I even gave you a stud vector full of these things. There's a tree. I guess this is probably for the parser. Image piece. Whoa! What is that?
What?
Yeah. Let's go. Element star const star const.
Is this legal?
It's legal. You can go. This is a combo, baby. You know how they say, like, what star programmer are you? Like, if you're a 1-star programmer, you've done code that's element star. If you're a 2-star programmer, you've done star star. But if you're a 3-star programmer, you've unironically used a triple star. And there are some people among us that have used 4. This is a 4-star programmer right here. Looks like so far in this code, I'm generally a 1-star programmer, but here I'm like 1 star plus because I got double consts.
It's pointer to pointer, but then for both you have const.
I think so.
Wow. So you can technically say another star and another const.
You can keep going. Yeah, you can keep going. I'm confused.
I guess it's a limit. There has to be a limit, no?
Yeah, because that's element star const. No, there's no limit, I don't think.
Like it's
you
like
probably blow a buffer somewhere.
This standard doesn't define like a limit.
Well, I mean, I can't see why you would have any limit. Why would you have a limit? It's just the compiler will probably overflow on some kind of type check, but I like it. I'm taking cons seriously. I'm taking cons seriously, you guys. I mean, you can't fault me for that. There's cons everywhere.
Yeah.
Static node, marker node, GFX node has a bounding box. Okay. I don't know what these are. Maybe there's names for these in SVG. LOD data. Okay. So what's an LOD?
LOD in SVG.
Oh yeah, we support LOD. Yeah. We support LOD.
How does it work?
So when you subdivide a Bezier contour, you have to choose how far down you're going to subdivide, and that depends on your pixel resolution, right? Because if you subdivide not enough, then everything is sort of, faceted, right? Standard geometric LOD stuff. So you want to subdivide close to like your pixel size so that things appear smooth. But if you subdivide so much, then when you zoom out, you've got your data is way too dense, right? And you've got too much of it. And so what you want to do is like subdivide less when you're far away. So that tiger was LODing too. It wasn't just like, ooh, I just drew it to the screen and it's fast. No, it's with LOD. So you could zoom out and the tiger was still fast. And you could put two tigers with low LOD and it was still fast.
Okay.
I think I had a lot of tigers. I want to find that tiger project now.
We need to, I think, slowly start wrapping up because if you want to do SVG and if you want to show the compiled game, or you don't want to do it,
I could. Yeah, no, that'd be fine. Look, we have a reference counter.
This would be Cosmos.
That'd be Cosmos. I could just run it and show it so people could see where this ended up.
Okay,
because it'll be kind of anticlimactic, but it'll be completely appropriate.
We can do it in the outro, like post-show part.
Yeah.
Okay.
Yeah.
Okay. So what's in there in the?
We're ref counting.
Yeah.
Ref counting. So we've got some kind of garbage collection. We have some friend class. Image must be like a pre-baked version, maybe. A visual is something like a protected LOD data. Has a forget static data. Has some node things. Has an owner, a ref counter. So this looks like it's ref counting some LODs, maybe. Maybe LODs get made as you zoom out on the fly, maybe.
Num nodes.
Looks like a raw array in the middle of all these vectors. Am I just...
And deleting them. Like, look at the memory management.
New and delete. Look, it's doing it correctly, deleting the nodes. Why am I not using a vector?
Wow.
Did I just learn about reference counting at this point and just decide to roll with it? Could be.
It's pre-shared pointers and pointers. So
that's right.
That's actually, you have either you're doing this like vector style, and like class style, or you're doing this, or you're mapping.
Yeah. So this is a shared pointer. Ref counter is probably a shared pointer kind of interface. Releasing data, print. And there's a library. I guess, you just load. Instead of giving straight access, let's give a way to give out visuals straight up. Okay, I guess.
Instead of giving
the one comment in the file is the first comment I've seen. This is the comment.
Visuals straight up. It's
straight
like
up.
Product manager vibes now. It's like, let's make it easy for the user.
It is. You got the library. Load VG. Why is it not a load SVG?
Because you're doing the branding, man. It's like, it can't be S. Wait, what's S stands for? For simple?
I don't know.
I think it's
simple vector graphics, probably.
So of course you couldn't write. It's not simple. It's actually very sophisticated. So how can you do it like SVG? Right. You need to be SVG.
Right. Well, since we're running out of time, let's peek inside. How is this actually implemented? Because let's see, how big is it? 1,000 lines. Not so bad. Just 1,000 lines. So this is kind of cool. 1,000 lines to render an SVG file. Like that's all you need to render tight.
Expat.h.
Expat, I believe, is a library that parses XML files.
Okay, it's scalable. I was roasted. It's scalable, not simple. Scalable vector.
Yeah, scalable. I was gonna say scaling, but yeah, okay. Look, single header library, nice. Maybe I don't know. Should I look? I won't look. We're using our triangulator. We're using IO. Why? I don't know. Okay. I guess maybe rendering. Rendering is part of the O.
For you kids at home, rendering is part of it all. It's, input, output, out. Okay? So, keep up. No,
but why is F stream should be part of I? Oh, well. We're going to use STD this time. We're not even going to try to decide. We're using all of it. We're going to use it all. Using VG, not bad. Okay, special effects. Oh, there's actually Oh, okay. Okay, so these are my special syntax because I think you can add nodes into SVG that are your own custom engine things. And so to mark things with special effects, I add this special effect thingy. And then I can parse it and I could say it's a special effect. So this is an extension for my game engine in particular to be able to mark up the SVG with special things. Finding IDs, rendering, computing open. There we go. Draw line strip. We're just rendering them. Polyline, making the polygon on the stack for each contour. Yeah, so this is the slow path. Oh, it's commented out. Why? Oh, must have been because I was like, that's too slow. Oh, there you go. Here comes some raw GL, but that's
also
commented out too. So there's just no render. I just decided this is bad. So all there is render stroke and probably render 2, right? Yeah, render 2 is still here. Okay, so basically, I just gave up on the slow path. The slow path does nothing. It just does nothing.
That's where you go when you go too far on encapsulation. Everything is too slow and you need to give up.
Exactly. So that's done. And then render stroke. So what are we doing in render stroke? Half width. Okay. Some pushbacks, pushing back some verts. I guess triangle, index triangle. Okay, so for every stroke, we're doing triangle strips. We're doing norm perp. Doing a little bit of line thickening. Okay. No mitering. I don't see any mitering or beveling. Oh, well. Return, render 2. Okay, so it's just going to do all this stuff. Do it to an offset.
While ++E. This... Like, I would need a minute to go through and understand.
You're not feeling that?
I mean, at this point, since I started to do like C++ like daily job style, I grew used to the decrement, increment, like postfix and like pre. Mm-hmm. It's fine, but I was so annoyed in the beginning, like with this syntax of like doing something in a loop. Not even like the standard for loop, it's fine, right? But if you're doing something like, I don't know, C outing something to show, and then you have a number, and then you put ++ there, and you're like, but it's like now you're printing, so why you're like changing? It's like changing, but next time it's like
next time.
I needed a minute, but
++ here, ++. I mostly do ++ on the beginning because I think the other one is harder to reason about, and also this one is faster.
Yes, I know this. This is
you know this, and you gotta save every cycle. Every cycle must be saved because that's what low-level programming is about. It's not what it's about.
Performance is about.
Performance right here. Look at the performance.
So you have your uint as well. If not none.
Yeah.
Then, okay.
Doing a little bit of couple of vertices here.
And this is ++E, and as long as it's not poly edge begin, why it's checking begin, not end?
Because I think the iterator goes in a circle because it's a closed contour, and I think it's like probably eating its own tail.
Oh, okay. Got it.
Yeah.
I mean, I'm trusting. Interviewer trusting.
Interviewer trust. I mean, that would be the only sensible reading of this. I think I probably felt like, polygons are closed contours and they loop. So, yeah, for sure. for sure. I'll bet money on it.
For sure.
I'll bet money on it.
There
See,
we have
even
it,
back
forage.
then.
Boost forage.
Is there any? I'm just gonna flex. Is there any other container that does a circular iterator in the standard library? Anybody who's like, well, kind of learned in the STD library? Because I was talking about the circular lists, trying to sell Wookash on this, and I'm like, I've been doing this since 2008 with iterators in a loop. I don't know.
From the sample ones, I don't know about any.
This may be the only instance I've ever seen. But anyway, whatever. Sorry, you were going to ask something?
No, I was just going to mention that there's a forage, the boost forage. If you go
there it is. There it is.
Even a little bit more up, like in the beginning.
Yeah.
Render tools,
Forage
like
contour.
Forage
Yeah.
contour, comma.
Bing!
Comma. I love that comma. It's like contour, comma, codes.
I mean...
Because
All right.
it's like if you call a function, I don't see commas as commas. I see them as separators. And if I see the forage, it's like, are we reading a book now? Like, is this a story? Like, is this the second part to what we started in the beginning?
It's functional. It's a map. It's a map over the list. Kind of. Not really.
Not really.
Not really. Not really. Some vectors, some namespaces, some no namespaces. So it's doing things. This is the main kind of stuff. And the compute closed is what's gonna... We didn't look at the geometry file because everybody knocked out. But at the bottom of geometry, there's probably Bezier stuff. Yeah, there it is. So there's Bezier compute. Given some vector control points, here's like computing a Bezier point, and this is doing it the standard I forget the name of the algorithm, but like the subdivision, I think so this is like a recursive Bezier subdivision, so it's not even a iterative one, which is like not ideal for performance, and it'll crash sometimes if you zoom in too much, I guess. Whoops. But then so look, a computation for quad splines. So this is what's actually doing the rendering for the SVG.
Nice.
Not bad for coding it on a laptop on a couch in university. And then they're just like, no, we're not going to do that part. Whatever that did. It's like, nah, just not gonna.
Not even commented out. It's just like, oh, look, we don't have time, We're so about performance. I don't have time to comment it out.
But what is this? Wouldn't you want to increment the offset?
You have it.
I have it here.
No, but this is total offset and this is total verts. So it's different.
Yeah, this is just wrong. This one's just wrong, but I'm just like, no, that's not right.
Let's keep it.
Let's keep it just in case.
It's wrong, but maybe in the future. Maybe.
Maybe.
We'll see how this
and then
goes.
this is probably debug code.
We laugh now, but this used to be advice, right? Like, hey, whatever the code is, maybe not like this, but keep it, like framework, keep it. Maybe maybe it's gonna be like useful for the next project.
It might be. It was. I did a couple of projects on top of framework. None of them compile anymore, but I did them. To do. This is happening more than one contour per path, i.e. no holes.
Preventing.
No holes. Can't handle holes. That's too bad. I know we handle holes later. I had holes in my ships, so I know I handled holes somehow. Yeah, so parser state. Okay, this is where the trees come in. So we got a parser going on in here. Ooh. Read vector. Doing some string stream. Okay. Haven't seen you in a while.
Nice.
Applying some trans. Parsing some colors.
Not a color.
Oh, that's where not a color comes from, because SVG has none. But why is it... There's no color. Why is it not no color?
Yeah.
I guess it's different.
Not a color is minus. So I don't know what's going to happen when in like GL code when you're like,
it's like minus. Yeah. GL will just clamp or show garbage. It won't crash. It'll be fine. Hexes. Okay, read some stuff. I guess, oh yeah, this is parsing the hex color. Okay, fair enough. Unable to parse the color, you get ugly color if you can't parse. Okay, Valve style, good.
Yeah, this I like. The naming a bit weird, but generally.
I mean, what would you
Could be
call
like
it? It's
debug color.
debug, but it's yeah, maybe. I think when you talk about it, it's like you want it to be an ugly color so it's noticeable.
Okay, but when you have no color, not a color, and an ugly color, you have like 3 logical ways to do one thing, and this to me is confusing. So if you had just ugly color and you just use it everywhere as the sentinel value, okay, I'm on board. But if you have,
I guess you haven't read enough.
Random ugly color.
I mean, if you read category theory, Wookash, these are all distinct cases, and so nil and null are not the same, and an ugly color is just for the user. It's not categorically different from a different color.
When did we get into category theory? We started in C++.
I didn't get into it. You got into it. I didn't get into it. Yeah. Get line. Okay. Yeah, we're getting some lines. Yeah, and on it goes. I'm mindful of time, but there's the XML parser, XML start callback. Parsing that XML, because SVG is XML. Getting some parsing doing it, computing. Oh, there's the buffers. Here's the VBOs. Trees have VBOs. Renders have VBOs.
Can we take a look at the VBOs? Quick look.
Yeah.
Why do we start with deleting buffers?
Well, if you have a buffer already and you're going to compute, you got to delete the old buffer.
Shouldn't it happen once you create a buffer and never touch it again? Or is it for the case? Or is it for the case of there's like small buffers for every path?
I think these are the small buffers. Well, these are the buffers in the tree. I don't know. No, these are for the graphics. This is the unified buffer. But it might have changed size, right? So just delete it and make it again. Because you can't resize a buffer. Or can you? Leave it up to the user. Exercise left to the user. Can you resize a buffer in OpenGL? But here I'm assuming you can't. So we need to figure out if it's a different size, then we're going to be remaking all them buffers, putting them. Look, these are back in the day when these were extensions. ARB. This wasn't even core profile. The core profile was immediate mode. So I was like, I'm going to get some extensions in here and get some VBOs. This is going to go fast.
Because we need performance for the Tiger. Tiger needs to go fast.
Tiger needs to. Well, I figured, okay, if I'm going to have a production-ready SVG render for my game, I ought to be able to have a test case. So I was like, what's the common test case at that time? It was Tiger. It's like, all right, let's render Tiger. If we can render Tiger at 60, render a couple of Tigers at 60, and it can zoom in and out, it's not a bad engine.
Nice.
Not bad.
If use VBO. And the other one doesn't. you get what you asked for.
Options. You get options. Yeah. If you want VBOs, you use the VBOs. Okay. I feel like I remember seeing...
What is the other one doing then? If not VBO, it's vertex pointer?
Vertex pointer, which I think will set the vertex pointer, and I think it'll copy the data automatically.
Okay, I never used
This is the old style where you just set it's not even pointer attrib or whatever, you just set the vertex pointer. Typically, I think when you use VBOs, you set the vertex pointer to 0 because it's like the start of the currently bound VBO, if I remember right. But here you're like, hey, here's a vertex pointer. It goes into like CPU memory, and it's like, cool, yeah, those are my vertices. And so,
oh, really? This is how it worked?
Yeah, just grab it.
Wow.
It's nice, right? It's nice.
Oh,
this feels good. It's like, here's my vertices, here's my colors. Let's go, baby. Here's my draw elements, triangle size, and here's the indices. Look, draw elements takes a pointer to the indices.
Okay.
It's faster than immediate mode, right? It's just you're doing the copy every time, but oh well.
I just had no idea that it worked like that. Like I got introduced to OpenGL when it was already VBOs and stuff, so
yeah. Yeah, sad.
Sad. If you say like, oh, there was an immediate mode, I was like, I'm already like, what?
Yeah. All right. Bounding box. Oh, finally, we get to learn about the bounding box. If not computed, okay, this is what I mean. Const, see? You can't compute anything with const, but if not computed, compute. Bounds, cloud bounds of the vertices. Computed bounds, true. Return bounds. There you go. Memoization.
So it's const, but it's also mutable.
Yeah. Because it's not const semantically. It's not it's const semantically, but for performance optimization, you can use mutable.
Mm-hmm. Nice.
I mean, it's not crazy.
It's not crazy. I agree.
It's not crazy. Yeah. It's an interesting idea. I could see how this comes around. People are like, oh yeah, const is really nice. I need to get to know what conceptually changes my file and what doesn't. That seems good. And someone's like, but for performance, I kind of need to memoize. And it's like, okay, well, those things will be mutable. Okay, I guess. So like it accretes, right?
Const everything by default, and then you explicitly make them mutable now to make them.
Well, I think the things that are like, I think what it's trying to be is like, okay, if you have a tree, adding a node is obviously mutating the tree because the tree is about the nodes. But the tree is not about the bounding box of the tree. So theoretically, you want to be like, look, I want to just compute the bounding box on the fly every time and kind of get the result by value kind of thing and all this stuff. It's not about the treeness of the class. It's about something else. It's like a query about the class. And so conceptually, from the tree's API perspective, it feels like it ought to be const, right? Because the tree hasn't changed, therefore it hasn't changed. So it's sort of like, and doing it doesn't change anything. But because of performance implementation details, const screws with you. So mutable is like your escape hatch for performance implementation. So like if you had a public mutable thing, that would be very naughty. But if you have a private mutable thing and you put a comment saying this is for performance optimization, everyone's like, fair enough.
Yeah.
Fair enough.
Approved. Go ahead.
Approved. LGTM.
Merge it.
Merge it. Flatten 2, blah, blah, blah. Looks like it just copies all the stuff. There's the new element const thingy, probably. Ref count, doing some ref counting. Visual constructor. So it's doing ref counting on the constructor. So these are true shared pointers. So visual is a true shared pointer. Look, we got copy from, destroy, which is doing ownership release. This is the shared reference counter.
And we commented out the logs so that it's faster.
Well, I mean, the logs were just for debug, but this has no bugs anymore, so we don't need the debug.
Oh, of course.
Right? But keep them in there just in case we have a bug again. Copy from. Yeah, so this is all the, so it's actually kind of cool because it's not only doing shared pointers, it's also doing LODs at the same time. So you can hold like shared pointers to different LODs. It's pretty sick, actually. It's a bit like immutable data structure world. I'm skip by before I realize it's not actually that, but let's just pretend. We are recomputing the B-box every time now.
Exclamation mark. You are so mad.
So mad. Damn. Stidman. Okay, there. Yeah, this is doing it. It's doing it. Copy notify.
Where to keep it? If it's like a, we
Where does it go?
We don't have the central storage because it's not OP friendly. Yeah. So where to keep it? There was no large arrays of things course.
No, there wasn't. Well, ironically, I didn't take databases, and I suspect if I took the databases course, because large array of things is basically like implementing a relational database. Well, I wonder if at that time, if I was taught databases, if I would have learned that, or if I would have learned something else. We'll never know. Oh yeah. Almost a 3-star programmer.
Wow.
A 2-star and a 2.5 star. It's a reference, not a star. Damn. I was so close. I was so close.
What? Okay, this is a point. Like when you said about the color or something that you would be like, hey, I don't know if I want to work with this person who wrote this code. Like I have my objections. When I see this, I'm like, do you have like 100% of understanding of this code? Because for me, it smells like you kind of like were doing something and just adding things until it's perfect.
No, I would have had good understanding.
Okay.
I would have understood what it meant, and I would have used it intentionally, but foolishly, but I would have known what this means. And what this would have been is like, basically, I'm trying to make a function that wants to operate on a double pointer thing, but I don't really want to add a pointer just because I'm passing it as an argument. So this one is like for the convenience of argument passing, and this one is like, it's a double pointer. That's what it's trying to say.
But you wouldn't type def GFX node double star, but you perfectly comfortable with type defing std vector poly something into mesh. Come on.
But because type defs are to reduce the keystrokes you type, Wookash. It's not for typing. Type def lets you type less. That's what it's called, type def. You define what you don't want to type.
You were so close to being a 3-star programmer, and you ruined it for the sake of reference. How dare you?
Yeah. Look, there's a deref in there. So it's going back to a single. Yeah. But, this works your cache. It's like doing mental math, It works your mental math kind of like, how many deep can you be?
It works my mental mesh.
It works my mash. My mash being worked. Look at this questionable ASCII art. Suggestive. Loads. Okay. Releasing some data.
Thank you for the support. We got live support member on the YouTube.
Hey.
For the jokes that we've done with the three stars.
It's not for the learning. Today we're not learning much.
We're learning what to avoid. No, it's actually not that. I would say for university projects, that's way above expectations, to be honest.
Thank you. This was my first time writing C++ as well, because before then I only wrote Java, probably. So this is like probably my first C++. The graphics course was in C++. That was the only course.
If you're coming from Java, then you have both things that would be useful, like common in Java, meaning like you have std map somewhere for like images and like stuff.
Yeah.
But then again, you have like double pointers, which would not be like the immediate step from Java, because it would be like, where's my hash map? I want to throw it in the hash map. I don't want to do like double. Give me my containers.
I might have taken C by this point, but I'm not sure. The way it worked in Berkeley is the Berkeley teaches kind of in reverse, or teaches like top down. So first you learn Lisp and scheme technically. And then that's in the A class. I don't know what they do now. Maybe now it's changed as well. But in the A class, you learn Scheme. In the B class, you learn Java. And then in the C class, you learn C. I just realized that might be a joke. But okay.
It kind of seems like...
Maybe it was on purpose. But anyway, usually you take like A, then you take B. And then once you take B, then you're allowed to take some courses that depend on B. And so like the compiler's courses in Java, for example. So I wrote this compiler in Java. We compiled Python to x86 in Java, which sounds like a kind of like a sick joke at this point. But you get a lot of language practice, 3 languages in one. And then graphics would have been in C++, so maybe I would have taken C by now to understand the pointers and things. So probably it's like I've taken C and I'm learning C++ because that's what we use in the industry and that's what graphics programmers use. So this is like probably something like that. Definitely less than 2 years experience for sure. It would have been like year 1 probably. Else visual is uninitialized. Good to know.
You also have like random assert there, which is like LOD has no group it belongs to, yet it's live. I've assert M,
Oh yeah, assert M is assert with a message.
Yeah, but this is in the D init code, or is it like, because it's in release something, right?
Releasing the data, yeah. So it's like, let's see if we can actually parse this. If it has a valid LOD, releasing reference for LOD, blah blah blah. Okay, and then it's like, let's find the LOD. Okay, so if it's trying to release an LOD, but it can't find the LOD inside the current visual, then it's like, hey, LOD has no group it belongs to yet. It's like alive as a shared pointer. That's not good. And so then you forget the static data. So this probably releases the buffers and the LOD. And then you decrement. Second is probably the shared pointer thingy. And then you erase probably the backing contour data. So you throw away that stuff because, save some memory. And this is, if this was the last one. So if this is the last shared pointer.
We're performant and efficient.
We're efficient. We don't want to leak any memory. We don't want to waste memory. We don't want to.
Nice.
And otherwise, we just say how many references are left. Just FYI. This is for debug.
All right, then.
Yeah.
I'm preparing a poll on YouTube. For a final rating.
Oh, yeah. That's right. We got to rate this.
SVG rating.
Okay.
There we go. 1, 3, 4, 6. Add an option.
And why don't I run the game in the meantime then?
You can prep the game, yeah. Start.
Let's see.
Or you're super ready for the game.
I mean, I can just run it so we can watch it while we chat.
I added 10 option, okay?
Hell yeah. That's what I'm talking about.
By the way, I should keep the same brackets, and I think every poll is different brackets. So chat is voting, and we then interpret what's the value.
We will interpret the
bracket
vote.
because it's only 4. Okay.
Yeah.
Can we?
Also, before you vote, chat, look up in 2008 what was the state of the art of SVG rendering. Context is important, right? Think of the performance.
Can you put the ratings that there have been, so that I think it's super important to contextualize when you're voting.
Right. That's true.
Not to have.
Or we can also drop the other ratings. Like we can compress the bracket.
Ooh, what do you mean?
Like if this ends up being a 5, then we can reevaluate all these back down.
But there's a 2. So if this ends up like an 8 or 9, then it's like the scale is perfect for whatever happened in language submodule.
True. Yeah. And it implements enough of the standard to render SVG Tiger, which was the test case back in the day for commercial libraries. 60 FPS on a laptop.
Nice. But that's actually I sort of now when you're doing something, I don't know to what extent you can expect that you will come up with something so close to sort of state of the art. There's so many things that are hyper optimized that when you're in the university, you're like, hey, I can create, a website and it will have a Postgres database and it will have a couple of tables, but you won't get you won't beat for example, text to speech model or speech to text.
Right.
It's
true. It's a different point.
So doing something with the mindset of hey, this might be the best library for SVG. Let's go. This kind of the motivation is
different.
Really nice.
It's fun. And I mean, if I remember right, I'm sure there were, I think Scaleform came shortly after or something, and Scaleform was like a Flash renderer. I think also used GPU. I remember there was a thing called Amanith VG, which was a thing that CPU rendered it, maybe GPU. But this was before Slug and all these things. And so it's not doing anything sophisticated, just subdividing. The idea here is, hey, let's put it on the GPU. No one really, I think, did much of that back then because, OpenGL immediate mode that's where we were at, kind of thing. I mean, people obviously did 3D stuff, but nobody was really looking at vector graphics. And I think Flash was CPU side, almost surely. And so to be like, hey, let's, you
might have had the first OpenGL VBO implementation of SVG.
It was like VBO was hot off the press, I think. Like we saw that it was, you needed extensions. And so I was like, hey, and clearly the non-extension renderer was too slow because I commented it out. So it was like, I mean, basically it just amounts to, hey, there's VBOs, hey, there's SVG. I just learned how to like subdivide SVGs into linear curves. I just learned how to triangulate. Those are the two pieces I need to put SVG onto the GPU, put them into VBOs and render fast. Like that's all you really, it's not a, gigabrain realization, but it's like pretty fun for a school project.
All right. I closed the poll and leading is the option 7 to 9. And there was 30%. It was for 10.
10 out of 10. We almost got 10 out of 10.
Okay. So I think that we're leaning towards the higher end of the bracket from the chat. Okay, like definitely.
I think
so
it's
like
9.
Do you have anything to add to the rating? Like skew it this or that way?
I would say.
Would you give it a 10?
I think out of all the things we looked at, this is probably the most like usefully sensible thing out of this whole lot. Like, I would probably, if I just needed an SVG renderer, if I could get rid of the XML dependency and the tessellator dependency, I wouldn't mind just putting that in as a first gut check and then testing things. It's how, I mean, there's a lot I don't like about it, but like SVG is not super trivial to implement, so this would save me time. But then again, it's just not modern with all the buffer management and all that stuff, but it starts to be non-sucky. I'd say it does not suck.
It's also like this piece didn't aim to be an engine or like a frameworky style, and you don't want to be like a math library, even though you had clearly gonna use like GLM or something else, so you're converting from one another. But it was actually like, hey, I have a problem and I need logic to solve this problem, and you can already see that it's way more useful than like the trying to build sort of like empire of abstractions.
Yeah, and the fact that I did LODs and automatic shared pointer kind of memory management is pretty good in terms of scalability. Like, you could imagine actually rendering a large scale game with this, and it's not optimal, but it won't sort of completely choke at some point because of the LOD system. So it's starting to feel production-ish, right? I'm starting to address production concerns. It's no longer like a toy idea. And yeah, like you said, it's trying to solve a real problem. So I'll give myself some kudos for that one. Yeah. It's a lot of lines.
I am leaning towards 9.5. I kind of like 10 is sort of reserved in my mind for like perfect things.
Yes.
So it's rough to be like, hey, let's give it a 10 because it's gonna be like, but it's like out of giving all the context that you've came from Java world and like 2 years of experience in programming at all, and like you have on one hand like star reference and like so this
I don't regret that.
SVG. I just found it in an interview. All things considered, I think like solid 9.5.
Okay.
All right, and this wraps up our live code review session with Anton on his old framework code from 2008. Now,
that's the game.
That's the game.
That's how far the game got.
So this huge reveal. This is it?
This is as far as I got in the semester. So you got ships, You can make, look, there's a hole. This must be so it's rendering SVG with a hole. There it is.
By the way, the zooming, is the zooming working? Do you have a zoom?
I can't zoom. There's a way to like edit them. If you click E, you can get into this view, which lets you edit the contours and make the ship. But there is another S. How do I get into the shop? There's a shop mode. I'm just hitting random keys at this point. F1? No. Okay. F2,
so if
F3.
Anton drops from the call,
yeah, it'll just be some
one button too many.
Yeah. So there's another way to get in, but the actual game looks like this. So if you select it, here you can fly it. Look.
Oh. Okay.
And you can't zoom in, but though I don't know, is there a zoom tool on Windows?
Yes, it was like the Windows Plus. Windows Plus.
Oh, Windows Plus.
Yeah.
Okay. Magnifier.
Yeah, and then you can.
Oh, wow. It's shitty though. But
you
see there's texture on there. That's all procedural generated SVG texture. Like there's rivets and stuff on them, and there's a little engine art, And then when you fly, look at that. There's fire.
A little bit of fire. Can you shoot?
Yeah, and no, because there's no guns on it. But the cool thing it does is like, I'm going off screen. It does this neat thing, which it remaps your controls to the thrusters, and it works out like which thrusters to fire in order to go left and right. So there's no like, you can make whatever ship you want, and it will like work out. So this ship can't like go backwards because there's no thruster going backwards. But I think another ship might be able to go backwards. And none of these ships have enough.
And we've seen reduce in action, the vector reduce, because it was slowing down the ship, because you don't have torque. You don't have.
That's right. That must be it.
So you have this like artificial slow in the space.
Yeah.
Nice.
Yeah. And the funny thing is that fire effect, that's the thing that I was that tiny, tiny little fire effect is actually running this math to do this pretty sick fire. But it's all running in like the 7 pixels or whatever that is behind the ship. So this was my fire test case.
Nice.
I don't know where the zoom is. So yeah, so that's running on top of Framework. And the game is too.
Mm-hmm. Framework. Like cool. You need a custom name.
For the Framework?
Yeah. Now we're popularizing Framework. We need that.
Well, it's Mosaic
for this that. Can we name Framework Mosaic? Mosaic is such a cool name.
I'm sure it's taken, but like if we all think the SVG part's the good part, right? Then it's basically Mosaic, right? Because that's all it really does. All this is leading up to the fact that like, in the end, what are these files like? Joystick, who cares? That's just SDL now. IO, font. Well, I guess font. But font can... I also triangulate the font, so I render font with triangles. So it's a similar kind of SVG hackery that's happening. I take all the text, I put it in the VBO. So really, this is an SVG-ish thing. So yeah, we should just call it Mosaic. And we'll say this is the premier framework for vector graphics, native vector graphics games on PCs circa 2008.
Soon, there's going to be 2026, maybe 2027, a competitor to Unity and Unreal. It's going to be Mosaic Framework. Okay, game editor from Anton.
And someone just asked, did I get to the online part of the MMO? Funny you should ask. I saw in the file list for Cosmos, there's client, but I did.
If you want,
and there is a server.
Zoom in.
Oh yes, sorry, I just show it. So in the file list, there's client and there is server. So the files are there. Did I get to the actual online portion? We'll never know. But the files suggest things. The files do suggest.
Thanks everybody who joined. Thank you, Anton, for courage to show code from 2 decades ago that you wrote. and walking me through it, and everybody else. Thanks everybody for a huge engagement, especially on the polls and the ratings. It was really nice. And see you next time. Bye everyone.
Bye-bye.